Hello, good morning, everyone. I welcome you all to the Global Conference on Machine Learning and Blockchain Technologies. Starting with our tradition, we'll light up the lamp with Mass Varsati Vandana. Now I would request Dr. Shweta Singh, founder chairperson of CIR, to address the gathering and also open the conference. Over to you, ma'am.
Thank you so much, Amisha. Good morning to all dignitaries and participants who are present here. I, Dr. Shweta Singh, welcomes you all in the International Conference of Machine Learning and Blockchain, organized by Council of Industrial Innovation Research and Sanskriti University, Mathura. Council of Industrial Innovation and Research is a not-for-profit organization. CIR is the new era of scientific and industrial research and development center in India. CIR has a pool of innovators and scientists working on the futuristic innovation for societal developments. We work on many areas which have direct impact on society, such as physics, geophysics, chemical, drugs, genomics, biotechnology, and nanotechnology, to minings and instrumentation in environment engineering and information technology. CIR main mantras lies in innovation, technology, intellectual property rights, and entrepreneurship. We are focused on hand-holding the various academic institutions and research institutions for futuristic and state-of-art technology and innovation to strengthen the innovation ecosystem of country with aligned vision of Atmanirbhar Bharat. CIR also provides the platform to exchange dialogues and thoughts among researchers, academicians, and innovators for creating a better and more innovative society. When we talk about blockchain technology has been trending in recent years. This technology allows a secure way for individuals to deal directly with each other through a highly secure and decentralized system without an intermediary involved. In addition to its own capabilities, machine learning can help in handling many limitations that blockchain-based systems have. The combination of these two technologies, machine learning and blockchain technology, can provide high-performing and useful results. In this conference, we will understand today the blockchain technology and explore how machine learning capabilities can be integrated with blockchain technology-based system. We will also discuss some popular applications and use cases of these integrated approach. Machine learning algorithms have amazing capabilities of learning. These capabilities can be applied in the blockchain to make the chain more smarter than before. And with this, I welcome once again one and all, and I'm very thankful to the university which is supporting us, and especially the Chancellor of the University, Shri Sachin Gupta ji, for extending his support for this conference and joining us today as guest of honor. Thank you so much, sir. Amisha, you can take it forward now.
Yes, ma'am. Thank you so much, ma'am. Now I would request our chief guest, Shri K.K. Agarwal ji, Chairman, National Board of Accreditation, New Delhi, to address the gathering. Professor K.K. Agarwal sir obtained his bachelor degree of engineering from Punjab University.
He will be joining in just 5 minutes.
Oh, okay, sorry.
So, in meanwhile, Amisha, we can request Chancellor sir to begin.
Okay, ma'am.
He'll be joining by around 10:15 or so.
Okay. Now I would request our guest of honor, Shri Sachin Gupta, Chancellor, Sanskriti University, Mathura, Uttar Pradesh, India, to address the gathering. Shri Sachin sir runs educational institutes, charitable hospital, charitable school for underprivileged and Divyang children. He has spent the last 20 years in variety of tactile industries, creating value, expertise, and growth. He is the youngest first generation chancellor of any university in India. He was conferred the youngest chancellor award by Her Excellency Srimati Pratibha Patil and Shri Ravi Shankarji. He has also been honored by Bharat Gaurav Samman in USA, beside a recognition award by Dr. APJ Abdul Kalam. Since 2016, Shri Gupta has discharging the duty of Chancellor of Sanskriti University, which is among the top-ranked university in our country, with a vision to create a university where people from all walks can come, learn, and play for excellence in life. Over to you, sir.
Very good morning, Chief Guest for the day in absentia, Dr. K.K. Agarwal, Shri K.K. Agarwal ji, Chairman NBA, Dr. Shweta Singh, all the team members of CIR, Dr. Rana Singh, Dr. Rakesh Premi, all delegates, very good morning. First of all, I would like to congratulate the CIR team and Dr. Shweta Singh for having organized this conference. And in these times, it is very important to organize such conferences and really impart the essence of quality and technology so that the delegates, the students and faculties can learn from this. Sanskriti University, established in 2016, is also poised to give quality education. And with the recent change in the pandemic times and change in the whole education scenario with virtual education and offline education, we are also poised to give the quality so that the students get the best delivery of education. Conferences such like these will always bring industry and academy together so that the requirement for the real manpower, the skilled manpower can be provided to the industry, and we can also explore the requirements of the industry. The topic about machine learning and blockchain integrated system is a very, in recent times, it's been exploring very well because of the, especially with the word called cryptocurrency exchange coming in. It has various applications, integrated systems like enhanced customer services, data trading, product manufacturing, smart cities, surveillance system, cryptocurrency, personal IT exchange, and so on. So I think the machine learning blockchain technology, people with this conference will learn a lot of with this conference today. At Sanskrit University, we have also started courses in machine learning and artificial intelligence, especially with the tie-up with Tata TS Ion, so that these days a lot of companies who have started these courses, they usually go through the NQT exams and other exams, and students appearing for these courses in Sanskrit University will not have to give NQT exams, and they will be directly recruited with TCS. This is one of the USP that Sanskrit University is organizing. Apart from technology, Sanskrit is also offering various courses in professional courses and in Ayurveda. We are also going to start up very soon 10 startups which are in technology and in other sectors. and we invite various applications. Sanskriti invites various applications from not only students but the people around Mathura and other parts of the country, being one of the incubation center approved by government of Uttar Pradesh, where we can incubate them and really move them forward for incubation and funding them for the startups. We have already started 3 startups in recent years, and this year we have going to start almost 10 startups. Yesterday itself, we have signed 7 MOUs with startup companies, and the UP government will analyze them. And we are very hopeful that those startups will go forward. And some of them are in technology also. 2 of them are with the IT sector, and one of them is related to blockchain and machine learning. So we are very hopeful that these exposure will give students a better exposure and will give a better dementia to the students around and people around who want to go into the entrepreneurship. As Dr. Shweta Singh said, that we're talking about Atmanirbhar Bharat. It's not only about giving jobs, but it's also making an entrepreneur. Because at one side, we say there are no dearth of jobs, but the other side, we need to make entrepreneurs. As Honorable Prime Minister Narendra Modi ji has said, we need to make our country Atmanirbhar Bharat and need to create entrepreneurs who can give jobs also. So the technology is one part which is used in various sectors, where you talk about agriculture, you talk about manufacturing sector, you could talk about servicing sector, and some of the cases where machine learning and blockchain technology have evolved is one of the I will share some of them. IBM has collaborated with Twiga Foods, which has launched a blockchain-based microfinance strategy for food vendors, and they have successfully implemented some of the techniques and determined credit scores predicting the credit worthiness of different users. And one other is Porsche, a popular car manufacturing company. They were the early adopters of technology where ML and BT are integrated, and improved technologies where companies use blockchain technology to trade different blockchains. New York-based companies using a blockchain-based innovation to enable energy generation. Energy is one sector where the climate change we're talking about. So blockchain and machine learning has also involved in enabled energy generating and trading of into local communities, where the energy can be communicated with the local communities in New York. And one of them is Unilever and Nestle. They have introduced in food disasters, wastage and contamination of food. So we can see that in various areas, this blockchain and machine learning is very important. So whether a student is going to an agriculture sector or an IT sector or any other sector, so machine learning and blockchain, data sciences, these are topics where he need to get into. So these topics are not only confined to what we used to call in early areas that we are a student of computer science or we are a student of agriculture. But with the new education policy, we need to learn different courses and technologies and what are they useful in the industries. So I'm very hopeful with this conference today. It will not only open the minds and thoughts of the people, and will also evolve them in making them think about the new generation that is coming and new technology that is coming in. Last not the least, we as students, because I always talk about students, we as students do not forget to charge our mobile chargers every night, but we forget to charge ourselves. So we really need to think about the future and plan for the future so that we can bring a better tomorrow, not only for us, but for the country itself. So I wish and congratulate CIR, Shiriel, and Dr. Shweta Singh and his team, and all the members of Sanskriti members for having organized such a conference. My best wishes. Thank you.
Thank you so much, sir, for enlightening us your knowledgeable words. Now, I would like to request our chief guest, Shri K.K. Agarwal ji, Chairman, National Board of Accreditation, New Delhi, to address the gathering. Professor K.K. Agarwal, sir, obtained his bachelor degrees of engineering from Punjab University and master degree from NIT Kurukshetra. Later, he did his PhD also from NIT Kurukshetra. After a distinguished service of 27 years at Kurukshetra, Professor Agarwal served as a Vice Chancellor GGU Hisar for a period of 3 years, and then as a founder Vice Chancellor of JGC Indraprasth University, Delhi for a period of 10 years. Professor Agarwal has published approximately 400 papers in reputed journals. About 50% of these are in international journals. He has been widely consulted by the industry, the most notable being of his contribution to the reliability analysis for PSLV. He was decorated with Lifetime Achievement Award by IETE and also by the Computer Society of India. Professor Agarwal has been associated with NBA in various capacities since its inception and was chairman EAC Tier 2 before taking over as a chairman NBA of 14 January 2019. Over to you, sir.
Thank you, Anisha. Friends, I'm so happy to be here this morning at the auspicious occasion of the inauguration of your conference on blockchain, machine learning, IoT, etc. Mr. Gupta, the Chancellor of the University, very well known to me for decades. Then Dr. Rana Singh, who has been nurturing this university for quite some time and contributing to academics at various fora in the country. I'm so happy to be here this morning for a variety of reasons. First is you are doing a conference in collaboration with another organization, which is Council of Industrial Innovation and Research. Now, that organization itself is created for the purpose of innovation and research, keeping industry in focus. And therefore, these technologies, machine learning, Internet of Things, blockchain, become an integral part of the whole mission of that concept. And then Sanskriti University has been doing some programs for quite some time, conducting various academic programs and doing some conferences also off and on. And if I remember correctly, I think I was present on one of their conferences even last year to address in the inaugural session. So I am very happy that the conference is being planned on these technologies. Well, if I talk about these technologies per se, there are some very beautiful factors about these technologies. One is these technologies, whether you talk about blockchain, cryptocurrency, Internet of Things, 3D printing, artificial intelligence, machine learning, augmented reality, virtual reality, anything you talk about, they are not independent. They are dependent on each other. And therefore, I believe one of the strongest things which we have to learn from these technologies today is how to depend upon each other. Atmanirbhar does not mean we will not depend upon anyone else. It only means we will depend on each other on equal terms. We will not be a beggar, but we will be ready to collaborate on equal terms. So that is where these technologies teach us how to do it. Artificial intelligence, I remember, I myself have taught artificial intelligence about 40 years ago or 35 years ago. Then for 25 years in the country, nobody talked about artificial intelligence. All computer science curriculums removed this course and so on and so forth. Why? Because the utility of artificial intelligence was very limited because of a data science not being there. After all, what is artificial intelligence? It somehow churns the data inside your brain and or inside the computer and gives you a solution. If you do not have efficient methods of data collection and data dissemination and data processing, then the utility of artificial intelligence is very limited. And that is what happened for several decades. So people stopped even talking about artificial intelligence. But then data science developed a lot. Today, data science is developed to that extent that it can feed artificial intelligence whatever it requires. So artificial intelligence gives you tools and algorithms. Data science gives you enough of data in the format you want, and then you can manipulate and get the results suiting your requirement. That is the beauty of the two technologies going together. If I talk about data science today, without artificial intelligence, its utility is very limited. If I talk about artificial intelligence without data science, then it practically stands nowhere. And same is, say, Internet of Things. Now, if you collect a lot of data, put a lot of sensors, everything, collect the data by Internet of Things. But then if data science is not developed, what do you do with this data? I mean, you just pile hard disks and pen drives by data and clouds by data, but what do you do with this data? Unless the data science is there. So Internet of Things will also have a meaning only with data science. blockchain. Now, blockchain is one technology, as Mr. Gupta was also talking about before I started. It is a very beautiful technology which really has the potential to almost eliminate wrongdoings, because you can have the track of complete trace. How did something start? Then what happened? Then what happened? Then what happened? The complete trace can be maintained by blockchain. And that is why something like as virtual as cryptocurrency can also be relied upon by people, because the complete trace is there. Who could play the fraud will be known at least all the time. So therefore, blockchain may have the great potential for a future. As a matter of fact, I read a beautiful article which says, well, when we can't say, but future elections on some point of time will be using blockchain technology. Because if you want to eliminate all the wrongdoings in elections, probably the solution rests with blockchain. And the article says many people are not comfortable with it for various reasons, but ultimately technology will prevail. In academics, if I talk about examinations, what do? You appear in second semester. The examination branch looks at what is your first semester result. Are you eligible to appear in second semester? Then can you be promoted to third semester? How much is your backlog in the first year? Now, all these things are so easy to be done in blockchain, because blockchain can have the complete trace of your movement. What did you do in first semester? What did you do in second semester? What did you do in third semester? And placement record, everything. What are the grades in every semester? What is internal assessment? So everything can be sequentially kept track of. And therefore, the work of examination in the universities will be very easy in future. Not only very easy, more important is we will be introduced many new things. For example, today many universities are afraid of a continuous assessment because the workload of data keeping increases. But if the blockchain is there, then let the workload increase. Teachers won't mind, students won't mind. I am chairman National Board of Accreditation, and we believe that the institutions should continuously improve, then only the accreditation or quality has a meaning. If I use blockchain, I think it will be very easy for me to have the complete history of the institution for last 50 years or last 20 years as to what were its quality parameters 20 years ago, what were its quality parameters 15 years ago, what were its quality parameters now, and then take a decision whether they deserve accreditation or not. Because I have solid cases that on our existing parameters today, they deserve accreditation, but they were far better 5 years ago. Now, if an institution was far better 5 years ago, today, even if they get passing marks, should they really pass? Because continuous improvement is a very focused point of accreditation. So one of the decision taking in future may be that whether pass marks is 40% is fine. But if you go from 35 to 40, we give you a pat at the back. But if you come 50 to 40, we may even fail you because you are going back or going down in your track record. Now, all these things will be very easy, even in academics, using blockchain. And therefore, I feel all the academic institutions will sooner or later adopt blockchain technology, not only for teaching blockchain technology, but using blockchain technology in their working, in their ERPs, which will be very, very necessary. Third thing I thought I'll bring to the August audience of this conference, because I looked at the speakers and the keynote speakers, I think a very great potential rests on the conference, and lot many collaborative technologies will be discussed. But let me also point it out that our national education policy now makes multidisciplinarity a way of life, a way of education. A student of engineering is allowed to take courses from other branches of engineering, and not only that, he or she may opt for some courses in music, some courses in sports, still get an engineering degree. Now, if you have to do that, what do? You take courses from maybe your university, other departments, or maybe other universities, and maybe online at times. Now, if you can opt for the best online professor in the world, then there will be a great challenge for our professors to start working hard to prove their quality. Otherwise, the students will have the option not to enroll in your class, but to enroll in an online class given by maybe a professor in America or Australia or so on and so forth. So therefore, I believe that the present technologies will give us enough option to sort of enforce quality in education by force of circumstances, that if we don't give quality, then the student has the freedom to register for any course anywhere. And therefore, there will be a very strong background force to move towards quality, and this technology will help. Friends, multidisciplinarity is easily said than done. To implement it will require a lot of mind scratching, a lot of thinking what to do, because it just cannot happen for the heck of it. Multidisciplinarity does not mean, say for example, if you have robotics in your institution, multidisciplinarity does not mean some courses in electronics, some courses in mechanical engineering, and you become a robotics specialist. Multidisciplinarity means you should have a real mixture of both these subjects so that you can apply it to robotics in the common sense. And when I talk about robotics, it's not only machines. People say that the humans and the machines will have to collaborate like anything. And the new terminology which I read in this context is cobotics. That is collaboration between human beings and robots. Because we may not be able to leave anything to robots also, not everything to human beings also because of efficiency. So we will have to think how much efficiency and how much purposefulness can be achieved by a common optimum combination of the two technologies or the two things. And therefore, I personally have very strong notion that with all these technologies, human beings will still remain relevant. Human beings will still remain very important because they will drive these technologies. And the day when we give in to the technologies, I think will be doomsday for the world. We cannot give in to the technologies, we can use technologies. And I think I'll call upon all the teachers and the distinguished delegates in this conference to ensure that technology is used by you very effectively, but on your terms, what you wish to get out of it. Let there not be a day when technology forces you that you must behave like this. And I remember a very beautiful article. He says, let artificial intelligence not make you naturally stupid, because that will be very bad day that when artificial intelligence takes over and makes you naturally stupid, you stop thinking, you give in to the computers, let computer takes the decision, and that's the correct decision. Even now, if you go abroad and all that, the sales girl, if you argue with her, she says, no, my computer says. Now, that's not the way of life which happens. And we will have to, I remember last time when we were in USA for a little longer time, we went for giving some clothes for dry cleaning. The girl has rates for jeans, rates for pants, rates for this, but she has no rate for shawl because there's no shawl in USA. She has rate for scroll. And she cannot, we argued, okay, shawl is 2 scrolls at best, so you charge the double. She says, but my computer doesn't have the rate for this. Now that is what I mean when I say artificial intelligence making us naturally stupid. I hope this will not happen, and we will use artificial intelligence, machine learning, Internet of Things, blockchain for the welfare of our country. And my focus areas will be agriculture, manufacturing, health, and education. We have to use these technologies for these purposes. Then only we'll be able to really make effective use of this. So with these few comments, I thank Dr. Rana Singh, Mr. Gupta, and all others for inviting me to this conference and share my brief interventions with you. I hope and wish the conference will be a great success. Thank you and wish you all the best. Thanks a lot.
Thank you very much, sir. We are indeed grateful to you. Thank you, sir.
Thank you.
Thank you so much, sir, for
बहुत
sharing.
धन्यवाद सर, नमस्कार, आपने समय दिया. Thank you so much, sir.
Namaste.
Thank you so much, sir. Thank you.
Namaskar.
Thank you so much, sir, for sharing your valuable knowledge with us. Now I request Dr. R.N. Beryl, Conference Chairman, to make his opening remarks. Over to you, sir.
Good morning to everyone. As conference chairman, I welcome all the guests, participants at the first GEAST conference, global conference on engineering, arts, science and technology. The theme machine learning and blockchain technologies was chosen because machine learning enhanced the way we communicate today and live our daily lives. Machine learning is also important because it gives enterprises a view of changing trends in customer behavior and business operational patterns, as well as it supports the development of new products. Many of today's leading companies such as Facebook, Google, Uber make machine learning a central part of their operations. Another path-breaking technology is blockchain. It is the technology that can reform, remodel lending, security, business models, and digital properties. The aim of this conference is to provide a common forum to researchers in the field of machine learning, artificial intelligence, IoT, blockchain, and other associated areas. As for the recent observations, I would say that we need quality research in these areas, in these fields, as it is felt that we are lagging a bit in this particular area. Talking about the term research, I would say it is nothing but a detailed study on a particular problem or concern for the benefit of mankind. Actually, it is for the help of mankind. And quality research provides solutions to these problems through scientific and validated methods. So I can safely say that the main objective of research is to explore the unknown and unlock the new possibilities. Let me talk about machine learning a bit. In 1959, author Samuel, a computer scientist who pioneered the study of artificial intelligence and described machine learning as the study that gives computers the ability to learn without being categorically programmed. Hence, machine learning is an application of artificial intelligence where a computer or machine learns from the past experiences, input data, and make future predictions. The performance of such a system should be at least at human level. There are different categories of machine learning like supervised learning, unsupervised learning, reinforcement learning, which the invited speakers are going to discuss today. Dear all, this conference is being conducted remotely due to the uncertainties related to COVID. However, experts from different countries will be connected with us today, sharing their thoughts, knowledge, and opinions. The major outcome that we expect from this conference is to discuss what are the benefits and challenges in the years to come. Lastly, it is my privilege to thank all the guests participants for connecting with us today. I hope in our future programs activities you will show the same enthusiasm, willingness, love, affection towards us. With this I conclude my talk. Thank you.
Thank you so much, sir. Now I would request Professor R.M. Mehra, Advisor, CIR, to say a few words. Over to you, sir.
Good morning and thank you, Anisha ji. Uh, First of all, I pay my heartiest congratulations to Dr. Shweta Singh, Director, Renewable IP. And the importance of this particular conference, international conference, that is on blockchain technologies, machine learning, IoT. One can, when I was searching the speakers for this particular conference, I was wondering how to find a speaker for this, because what I found on that there are bureaus for the experts in blockchain technology, and we have to book their timing, their dates, and then that we have to pay them on Radium in thousands of dollars, $10,000 per lecture or so. whether it is they are speaking to all over world, So that shows the importance of this blockchain technology. And of course, I congratulate Dr. Rudra, Dr. Ayush for organizing such a conference on very important topic, which is useful in all sectors of life, human life. Whether it is corporate industry, whether it is education or anything. So, and this CIR, Council of Industrial Innovative Research, is doing in a very short time is doing wonderful work and bringing people together to discuss important topics. And this is the first international and two national conferences have already been conducted. I'm I think what I remember with communication with the chairman, Dr. Rudra, there are at the moment here, if I look at the nearly 61 participants for this conference, that also shows an importance that people are finding this a useful activity. And there are more than 15 registrations and around 20 research papers people have contributed from India. So I think this is a very good participation. So with so many registration and with so many contributions, then I'm thankful to Dr. Anand Nair, Dr. Sanjay Mishra, very special thanks to him, and in respect of Dr. Sanjay Mishra, who is uh, in Nigeria for many, many years, but always traveling, so difficult to connect him. So he will say, sir, I'm traveling, I write you at 1 a.m. and like that. So Dr. Mishra, if you are hearing me, I'm grateful to you. And how did I locate Dr. Sanjay Mishra? Through one of my PhD student, who is one of the speaker also today, Professor Anurag Mishra. So Anurag, I'm very happy that you have been helping me in all my activities, whether I was in University of Delhi or now in Sharda University or joined doing some contribution to CIR. Then Dr. Prakash Srivastava, I'm grateful. He is also one of the speakers. Then, I have a lot of connections, still live connections in Japan. I have been in Japan several times, more than 25 times or so. And so I am, uh, first of all, I say Ohayo gozaimasu to Shohei Kake Sensei, if he is hearing me, and Kotaru Suzuki Sensei. Sensei is teacher, in Japan, we don't, students, and when we meet a teacher, we say Sensei, Ohayo gozaimasu. Ohayo gozaimasu is good morning. And whenever something we want to pay respect and other thing, we say Arigato gozaimasu. Thank you very much. So I thank Professor Shohei Kakei and Professor Kotaru Suzuki for their contribution, and they will be speaking in this conference. So it will really, a great effort and great achievement by CIR and Shweta Madam. And then I'm also thankful to Dr. Sunita Yadav. She is also with us many times, every time. And thank you, madam. I'm very happy that you are here. And it's a real player, matter of player. That person like eminent person like a academician, a scholar, all qualities, and an administrator, Dr. K.K. Agrawal. Oh, fantastic. Whenever he speaks his, whatever he speaks is truth and truth only. He speaks his mind. He is versant in all the fields. He is chairman NBA. He was vice chancellor, I think, in the IP University. So I'm grateful to you, Professor K.K. Agrawal, that you have been with us and you are with us all the time for this particular conference. And then uh, not the least, the Chancellor Sanskriti University. we have the CIR and EIP and Shwetaji individually has extremely good relations and support every time from Sanskrit University Chancellor and Vice Chancellor. So I congratulate all, and I'm sure that all the participants who are here listening to these lectures, they'll be greatly benefited. And as Dr. Rudra has said, that there are, we are, I mean, Dr. K. K. Agrawal also has mentioned, Rudra has also mentioned that this field in India is still in the developing stage. And so this is the right time, right moment that an activity with such an eminent persons, speakers, is being organized by CIR. So once again, I congratulate Shwetaji and all the team members, and I welcome all the members, all the participants who are with us today. And thank you very much. Thank you very much. Anisha, thank you very
Thank
much.
you so much, sir. Thank you so much, sir. Now, I would like to welcome. Now, I would like to welcome Dr. Rakesh, sir, to deliver the vote of thanks.
Hello, can you hear me?
Yes, sir.
Yeah.
Yes.
Let me introduce Dr. Rakesh first. So so we are now having Dr. Rakesh Premiji. He is officiating Vice Chancellor Sanskriti University, and he will be delivering the vote of thanks for today on behalf of Sanskriti University and CIR as of this conference for this conference. And we are very great to have him here on this platform and to hear his word during the vote of thanks.
हाँ सर है Hello, Shweta ji, can you hear me?
Yes, yes, you are audible, sir. You are audible.
So, as a matter of fact, I was thinking the conference would go long, and I believe we spoke that around 2:30 or 3 o'clock.
Yes, yes. So I was in picture that vote of thanks for the complete conference going last, but they have decided the vote of thanks for the inaugural panel should be delivered by you.
Okay, then just now. Sorry, no issues. So, Honorable Chancellor, Shri Sachin Gupta ji, of Chancellor of Sanskrit University, Shweta ji from CIIR, Professor K. K. Agrawal, whom we just heard his words of wisdom, Professor Mehra and Mr. Rudra. Needless to say that the importance of blockchain technology and artificial intelligence, machine learning, they are bringing a lot of changes in the entire world. And the world we see today, the productivity which we witness today is going to witness a sea change in coming future. And I think this coming future is not very far. It is so near that most of us may be not even able to predict. So I'm really thankful to all the speakers, our Chancellor Sir, Professor Agrawal, Mehraji and Rudraji, for giving us such fantastic insight into the world of technologies which is evolving probably every minute, day by day. I'm sure I'm thankful to all the participants also who are making this conference very successful. And Shwetaji, I must tell you, there was some important session which was going on. Very soon our students and faculty members are also joining. I really regret and apologize that they were not able to join because there was something already scheduled. They'll be joining very soon. So I'm thankful to all the delegates, all the dignitaries, our Honorable Chancellor, for having this conference being possible and letting all the stakeholders add value to their self. Thank you so much, Shweta. Thank you.
Thank you so much, sir. Now we will be starting our session 1 sharp at 11 a.m. welcome back everyone to our first session of the conference. I would request Dr. R.M. Mehra sir to become the session chair. Now, may I request the keynote speaker, Dr. Anand Nair, Assistant Professor, School of Computer Science, Tang University, Vietnam, to address the gathering. Dr. Anand Nair had received PhD in Computer Sciences from Desh Bhagat University in 2017 in the area of wireless sensor networks and swarm intelligence. He is currently working in the School of Computer Science, Tang University, Vietnam, as Assistant Professor, Scientist, Vice Chairman, and Doctor. Director, IoT and Intelligent System Lab. He is certified professional with 75 plus professional certificate from Cisco, Microsoft, Google, and many more. He has published more than 125 research papers in various high impact factors, SCI and Scopus Journal, 50 plus papers in International Conference Index, Springer IE, Explore, and ACM Digital Library, 40 plus book chapter in various Scopus Web of Science Index with Springer, CRC Press, and many more, with citation 5000 plus, H Index 36 and I Index 126. Member of more than 50 plus association as senior of life member including IEE, ACM. He is currently researching in the areas of wireless sensor, IoT, cloud networking, artificial intelligence, blockchain, cybersecurity, and wireless communication. Over to you, sir.
Thank you, ma'am, for the introduction. Can you hear me properly?
Yes, sir.
Okay, great. Can you please give me the permission to share the screen, as I can say that host disable participant screen sharing?
Yes, sir. Okay.
Great. That's okay. Thank you. Okay. Can you see my screen, ma'am?
Yes, sir.
Great. So good morning, ladies and gentlemen.
Good morning, sir.
Ma'am, please mute the participants. Thank you so much. I don't need any disturbance. Thank you. So good morning, ladies and gentlemen. I'm Dr. Anand Nair, and I'm working as professor, scientist, vice chairman research, and director for IoT and Intelligent Systems Lab in School of Computer Science, Dutan University, Da Nang, Vietnam. First of all, I'm very thankful to the Vice Chancellor, the organizers for this conference to invite me as keynote speaker. It's a real honor for me to be there. Now, talking to the conference theme, which is towards machine learning and blockchain technologies. As we all know today, we are using machine learning right from the Google search to our smartphones, to our smart homes, to Industry 5.0, and of course, from drones to even to intelligent technologies. You will see that we are actually interacting with the gadgets, but actually these gadgets are working as per our response because of machine learning. And machine learning is not a subject. It is basically a technology. It is basically an era that is transforming the today's world into intelligent world. Now, talking of your smartphones, imagine a decade before the technology when we used to have some Nokia and LG phones, when we were just opening up some apps, we're using the Java archives. And of course, we don't have any professional digital cameras on board. And some players were even not having good musics and even streaming services. But consider the iPhone of today, consider the Google Pixel, and of course, like machines like iPad, and talk of industry of cyber physical systems, drone technology, you will see that machine learning is impacting everything. So in today's lecture, I will be talking about machine learning only. And of course, I will be talking about one more area where me and my lab is actually contributing a lot in terms of machine learning and AI, that is in terms of healthcare. So if you search my name on the Google, that is with Anand Nair and Healthcare Technologies, you will see that even me and my university have designed robots for airport, the robots for hospitals, the Internet of Medical Things, and even we have designed blockchain technologies for healthcare systems. So in my lab, our main focus is to design of AI technologies, and we have to integrate with intelligent systems. And of course, we have to progress more in towards the sophistication design and development. So ladies and gentlemen, without wasting the time, I will be first of all coming to the part one of my lecture, which will be regarding the machine learning. So as I was expecting the lecture for Bitcoins, the future of the currency, but as I was requested by the coordinator that please, sir, if you can focus on machine learning more. So that's why I changed my lecture yesterday to machine learning. But we will be having lots of information to be discussed. And believe me, when I was designing this presentation, I was having so much of information that I was not able to understand. Please mute yourself. Madam, it's a request to you. If anybody is unmuted or he is disturbing, please make him away from the conference, please. I don't want disturbance now, please. This is my strict rule. This is my discipline, actually. So as I was talking to you, because this breaks my, you can say, the continuity in the lecture. So as you can see that if you talk of only machine learning, you will get, you can say more than 1 million of search pages on Google. So machine learning is everywhere. If you search on ebooks, you will get lots of ebooks everywhere. But the main thing is what exactly is machine learning? Now, let me talk in a very simple sense. When the human beings take the birth, so you are like an infant and you don't know what is ABC, and you don't know how to read the stories. You don't know what is red color, what is blue color. You don't know what is male, what is female. You know nothing. And similarly, we start learning. So the learning is known as the basic process or the foundation of human mankind. The more you learn, the more intelligent you become. Similarly, in terms of machines, when you have the machines that are traditional machines before expert systems, what they have, simple, you put the input, you have some algorithms and they produce the output. But now we want to design another kind of machine where we don't have to program much. We know the input, we know the output, we train the machine, we make them more intelligent, and then we test the knowledge. Like suppose you go to the market and you want to learn Python, the only output is you want to produce the output of programming. You know the output, you know the input while learning, and of course you are learning the language. So machine learning is nothing, it is basically a learning from experience. And similarly, the machines will be using this technique or this technology in order to make them better and best. So don't think that with machine learning, we can attain 100% sequencing and 100% results in everything. We need to make sure that the knowledge and learning, it keeps on improving. I am a professor of computer science. I'm a professor of artificial intelligence from last 10 years. I'm teaching AI, I'm teaching ML, I'm teaching DL. Even we are doing some lab projects with regard to TensorFlow and other things. It's a huge things that we can do. But the main thing is that we need to understand what are the foundational concepts through which you can build up your intelligent machines. So with the start of the lecture, I would like to tell you that today it will be an introductory lecture for all of you, that if you really need to understand what exactly is machine learning, what is actually the confusions that you have in your brain, I will be solving that. And after that, nothing, you can say that you're all welcome to ask me the questions. Okay. And after that, I will be also telling you one book of mine, which is known as the biggest book ever written in the machine learning area. So I will be showing you that book in the end of my lecture. So let's start the lecture, everybody. So what is machine learning? You can see that I have given you a very important definition. So you can see that learning. Now, what is learning? Machine means computers. And what is learning? Learning means it's an activity. It's a process. Now, today, if I tell you that, okay, sir, let us take some online lectures and let's learn Red Hat Linux. Now, you don't know what is Linux. You don't know what is ls command. You don't know what is kernel. You are actually learning. You are reading with the books. You are becoming more expert. So similarly, if we want to improve the intelligence of the machines, like, okay, I tell the machine, okay, this is a data set, this is ice cream, this is toy, which means I have to give the machine tons of the images of toys and ice cream. And after that, the machine will able to understand, okay, sir, this is ice cream, this is a toy. So the main thing is more data you input, more experience you put in the machine, more you can say more different varieties of input you put in the machine, the learning process becomes improved and improved. And that's how you keep on training the machines. So don't think that training becomes a different thing. If you want to build up an autonomous system, even that autonomous system has a learning capability during the neuromorphic processes. That is a future, but I will be coming on that. So what is learning, everybody? So we all know the first scientist of AI, which is known as Herbert Simon. According to me, he was the first scientist, but Alan Turing is one of the main person who laid the foundation of modern computer science. Okay, so remember that. Lots of people have given lots of things. Lofty has given lots of things in fuzzy logics, but all these people have laid the foundations. But if you talk of the most prominent person of machine learning, he is Andrew Ng. And even if you go to Coursera, he's the CEO of Coursera. He has given lots of courses of machine learning on Coursera. So learning is a process. You can see it's a very simple definition. Learning is a process through which you improve your performance from experience. So similarly, if I put those data or put that information in the form of data and give the machine to give learning, it is actually improving. So don't think that machine learning is 100%. We can build up the model up to 95 or 99%. My highest accuracy in the model building is 98.71%, which is the highest till date in breast cancer. So definition by Tom Michel. You can see the definition is very crisp and clear in front of you. Okay. So definition is very crisp and clear in front of you. What is machine learning? It is basically known as study of algorithms. So many people ask me this question that, sir, if you want to become a machine learning engineer, what we need to give the input? So I always tell you that first of all, learn algorithms. You have to learn the structure, that is the data structures. Of course, you need to have a strong knowledge of mathematics. And if you don't have the knowledge of these things, you can't become a machine learning engineer, because where the algorithm makes programming, but of course, we have to derive everything mathematically. So machine learning, it is basically known as the advanced study of algorithms through which we improve the performance, that is P, on some task that, okay, sir, we want to detect that whether the image is of a boy or a girl, or whether it's an ice cream, or whether it's a mosquito, or whether it's a table, chair, anything. We are giving the input to the machines to perform some task, and we are improving that performance with experience. And that's the reason, everybody, we always give the question that, okay, which data set you have used? Okay, sir, you have used that data set, but have you added some your own information? So don't think that only if you have added some data set, you are putting up some model and the model is accurate. No, the model is accurate to a certain extent, but after that, you have to improve the experience. After that, only the task improvement can be done. So you can see the learning is given with a derivation when three things are combined together, that is performance, the task, and the experience. So remember that PTE is the formula through which the machine learning takes the foundation. So that is actually known as the foundation and the opening step, that what exactly is machine learning. So you can see, everybody, what is machine. So first of all, remove machine learning from there, just focus on traditional programming. So if I tell you that, okay, make a program and we need to add two numbers. So what you will note, you need to declare two variables for addition of the input, and you need to declare one variable in order to produce the output. You need a formula. You compile that program with particular syntax, make it sure that there is no logical and compile time error. And you can use any language, whether it is Java, C, or Python. And of course, you compile the program and you get the output. But so this is traditional programming, when you have the data, when you have the program, and you give it to the computer and you get the output. But machine learning is not like that. So you have the data in form of data sets. You know what should be the output. Of course, you know the output, because why? You want to detect the machine. You want to make the machine intelligent, that, okay, if I give you any image from the internet, find out whether the image has a boy or a girl or an ice cream or a toy. You have the data, you know the output, and of course you have the computer. And in that computer, we give the data sets, we give the algorithms, we give the learning model, and after that we generate the programs. So machine learning is nothing. It is basically the outcome of programming, that is taking data and output as the input. And of course, with the algorithms, we are improving with experience, and the program, you can see the program that is coming here, it becomes better and better. So the main answer for you is now that more data you give, more output or more models you give, the better is the program and better is the intelligent system that you create. So it becomes not complex, but you need to understand that what exactly is machine learning. Okay, so suppose if you want to make a robot, okay, and you want that robot should pick up like a simple glass or other things. So what you need NLP. So the machine should understand that I need to have the glass. Glass means that this is the object that needs to be picked up. So the machine has to be NLP programming, and of course the machine has to take a decision with object recognition. So that's the reason, everybody, machine learning is interesting, because we have the data into control, we have the output under control. The only thing is we need to make the machine to become better and intelligent to give the derived output like human beings. That's the reason with machine learning, we are making up the machines equally intelligent like human beings. So that's the outcome of machine learning. That's the best definition I can give it to you. So when do we use machine learning? Now, this is a big question. Like suppose we कहते हैं ना कि we are not antaryamis. We don't know what is going to happen, but we know what the data is being generated. Like I will not tell you, because today, actually, I'm sorry, I would have focused on Bitcoins, because I'm happy to inform you. Yesterday, I made, 10 days back, I made an algorithm through which I can detect what could be the prediction of 3 currencies. I'm sorry, I cannot declare it publicly, but in last 5 days, I earned 675 US dollars. So this is my algorithm that is working. So means that I give the data and I make the model, and the model predicts for me. I know the future. And believe me, my model has given me 56% accuracy. And with 56% accuracy, I earned $600. Now imagine if I perfect that model with 90% and I give the input of $1,000 in the real time, which means I can earn $5,000 in 10 days. That's the beauty of machine learning. Now say this, everybody. Now we don't know what is happening in outer space, but we know the inputs of outer space. We want to make the machine, whether the machine can be able to adapt or not. We make the environments, we make the machine learn. We don't want to go actually in that environment, but we want to understand that what exactly will be the environment there. So for that, we don't have that particular experience, but the machines can be learned. So ML is used when human expertise does not exist. Now imagine, everybody, if I want to go to Jupiter, but we don't know whether we can survive in Jupiter environment or not. But first of all, what we do, we just send the machine, we predict the data, and then we can make some calculations that what exactly is the environment and what is the do's and don'ts there. The biggest example is in front of you, that is the Mars rover. Second, humans can't explain their expertise, the speech recognition. Today, if you talk that, okay, hey, Google, turn on the lights. So it is actually known as NLP. We have the keywords. Hey, Google means that, okay, Google, please activate. And of course, turn off means the lights that needs to be detected, and lights are being controlled with your Siri or of course with your Google Home, and they will take the action. So models need to be customized. Now, the biggest problem in the world is COVID-19. And believe me, if you search COVID-19 with my name on Google, even we have designed some models through which we can predict. And believe me, till date, my model is the 6th highest accurate model in the world in terms of COVID-19 deaths prediction. So models actually based on tons of data. Now, suppose I know that most of the people know about the character called Spider-Man. Now, in the Spider-Man, if suppose a medical company is making some injections, okay, like suppose today I want to make a drug that, okay, I can improve the capability of the human beings, but I make the injection, maybe that injection is perfect or not, I don't know. I need to have some human beings, I have to inject them, but what will happen? Maybe I can turn into a zombie. Maybe the human beings can react indifferently. Maybe he can get weak, maybe he can die. So what I can do, I can take the gene DNA sequencings, and I can put that sequencings in terms of like a synthetic biology in the computer model. And I then put that chemical reaction, and I can understand what exactly will be the reaction of that medicine on the human body. And once the reactions are being stable, I can test that drug with a clinically approval that, okay, now it is ready and I can test it on the human beings. So that's the reason, everybody, when complex situations arise and we don't have a live subject, we don't have particular concrete evidence that what can happen, machine learning is able to do that. But let me awaken you, everybody, that in every situation, it is not like that. Because till today, if you talk of brain cancer, synthetic biology, of course, with the COVID-19 vaccinations, chatbots, we are still not into the era of perfection. We need more time in order to give and to deliver best results. So machine learning is giving us everything. So you can see, everybody, a classic example of a task that requires machine learning. Now we all know, I think everybody knows about Apple Watch. And when the Apple Watch, any message comes to you on WhatsApp that, hello, sir, how are you? And of course, you don't want to pick up the phone. You just put on reply and you draw some characters, I space, I am fine, which means you draw A like this, I draw A like this, which means the machine is actually predicting the characters that are being written. And of course, with that prediction, the machine is translating the particular A in perfect sense. Now imagine everybody how much learning is done on the Apple Watch. Now imagine if you are putting up lectures online and you're using like iPad, and of course I'm doing handwriting and I'm writing anything and it is converting into the exact text in the form. It is called natural language processing. And of course, this requires tons of hard algorithms, tons of models that needs to be predicted. So imagine everybody, if you are using Apple Watch or iPad or iPhones, how much backend based learning experience is being added to these gadgets today. That's why these processors are becoming better and better, from A14 to A15, then A16. So even that's the reason everybody, you can see latest keynote by NVIDIA CEO. Now we are coming up with intelligent data centers. We are even coming up with quantum computing. So with that quantum computers, we can improve better and better. We can add more data, perfect the machine. So some more examples where you can provide the learning algorithms. You can see facial identities. Like suppose if I come in front of my Face ID, I think everybody knows about iPhone. And of course, when you put like open and you are using Face ID, even your Face ID is even using a learning algorithm. When you detect your face, it detects certain positions. And after that, it pattern matches your face and it can do the unlocking of your phone. So even your biometric system today, if you unlock your PCs or mobile phones today, it is all with a learning experience. Handwriting. If you speak some words, like suppose these days chatbots are very important, RPA, robotic process automation, it is coming. It's a very good area to do the research. And medical images. This is my specialization. We do lots of research on medical images. My highest research is on gastrology, breast cancer. And of course, now we are working more on brain tumors. Generating patterns. So these days, even you can see one of the book which has been released by Elsevier last year, that is GAN. Now computers can take some image and they can generate some fake images also. We can even generate the fake video also. We can regenerate some motion sequencing. Of course, this is very, very crucial for us. So GAN is one of the area which is a huge progressing in the near future. Recognizing anomalies. We all know that, of course, like in terms of cyber security, like I am a cyber security expert, I'm an ethical hacker, and of course, I'm a penetration tester. We get lots of anomalies, we get lots of packets trying to enter the network. But between your network and outside world, we have firewalls. Now, how the firewalls know that which packet needs to enter and which packet needs to get out? It is only with the part of AI algorithms. And of course, with machine learning, when the new packet enters, it finds some anomalies. And of course, it learns and adds into the brain that, okay, sir, this packet is more advanced. Now I learned it. And of course, this packet will be discarded in the near future. That's the reason today machine learning is evolving to deep learning. When we don't have to program, when the machines are programmed with basic knowledge and learning, and with the real time, they are improving their knowledge like anything. I will be telling you about the techniques after some time. So we have to do the prediction. As I've already told you that I made an algorithm 10 days back, and I added that algorithm for predicting with historical data. I put that historical data of 4 years in that system of mine. And we have done all these predictions and everything on the cloud, because in the real time, even though I have top cloud computing, I have the top machines in my lab, which are already running with the RTX 2093 graphics card based cluster, but still we need tons of data to be processed. So that's why now my machines are readily available on Amazon, that is Amazon cluster. They're highly scalable. So I'm putting up that data set on Amazon, and we are processing everything on our on the another cluster. And of course, we are integrating them and we are predicting the answers. And believe me, I have earned a lot of money in terms of currencies. And now soon I will be adding up more data towards stock exchange. Even you can see some of my papers that are written on prediction of stock exchange prices. And that model is even accurate up to 70%. So some of the sample applications that you can see on machine learning today that you can see is web search, computational biology, that is synthetic biology today, the financial transactions, e-commerce, space exploration, information extraction, social networking, debugging. So the main thing today, if you're talking of Facebook today, and if you upload a photo of your friend with you, it automatically detects who is your friend. So this is even called a face recognition based criteria that is working on Facebook. If you're talking of AR and VR, when we talk of HoloLens 2, Oculus Rift, and even with Google Daydream, they are all using these type of algorithms. And of course, with e-commerce, like if you go on Amazon.com or IN, you just pick up an iPhone and automatically it shows you the recommendations that, okay, sir, you're putting up the iPhone. So please add some cover. You can add some screen protector. You can even add a Bluetooth speaker. That is even a recommender engine that is being recommended to you on the basis of your search by the engine of Amazon, which is learning from you. Now, suppose if you're buying the iPhone and you add one more thing that is with regard to your not cover, not other thing, but you are adding up that is maybe called a book. So even in the future, it learns that maybe if a person is buying the iPhone, it is also buying the user manual also of this thing. So in the future, if I buy the iPhone, that thing also comes under the recommendations. So this is one of the area, everybody, where I love to play. And of course, even today, we are mastering 3 things right now in my lab. We are working on designing the AI-based games. And even we have done one research also that we have taken 2 gadgets. One is your Apple HomePod and one is your Google Nest. And we have taken a computer-based AI machine in which one player is Apple HomePod and one is Google. So we have seen that we have taken the machines to play with each other and Google has won. Yes, Google has won. And now we are putting up more AI in terms of robots can speak with robots. So this is one of the chess playing. Of course, we are learning with Need for Speed game. And of course, I'm working with one more company and they have sent me one retro-based gadget and we are adding up more games, how we can play the games better, like Contra, how to get the highest score. And even like Flappy Bird, one of the best games that we have seen with AI. So all these things are actually requiring lots of intelligence where human beings have some limitations. So let's see with machines how better we can improve the gameplays. So basically, what is machine learning? It is basically the ability of computers to learn without being explicitly programmed. So you program the machine one time and improve the data, keep on improving the data. It improves with the model, it adds more data, it improves with experience. So similarly, if I put one game of chess, whether it is a losing game or whether it's a winning game, I keep on adding, believe me, the machine will become more and more intelligent. So defining the learning task, you can see improve on task T with respect to performance based on experience. Now see this, everybody, the task is playing the checkers. Performance is percentage of games won on arbitrary opponent. I have to see the task that how many games are won by the opponent, and after that, how many words are being satisfied, what was the distance, and of course, what was the database. And of course, the experiences, we have to play the game itself. We have to improve the database. We have to observe the sequences of images and commands. And of course, after that, we have to improve the gameplays like anything. So this is how we improve the game of chess. So similarly, if you are playing Contra and the game comes to know that, okay, sir, you don't take decisions when an opponent is coming in front of you and the back of you, you don't have best reflex action. So they will tell you, okay, when you're there, just shoot 2 times in the front and immediately shoot 2 times at the back, you will not be defeated. And even in the future, everybody, what we can expect is that when we talk of NVIDIA Cloud Engine or Google Cloud Engines, we can even, like we are playing a offline game like a Thief of Tsunami, like a game that I play. Even I'm a good gamer and I play Call of Duty games. Sometimes I don't know which stage, how to get off from that. I play it, replay. After that, I go to Google, YouTube and play that. But rather than I play the game, I freeze the game there. And with machine learning engine, I am able to understand how to play that game at that stage. So this is what we can say. We have to define the tasks that need to be performed. We keep on learning with sequences and we can become the master. So the state of the art applications of machine learning. So I can talk on this topic even for 10 days, for 20 days, because I'm doing machine learning from last 10 years. Even I'm a professor of AI from last 10 years. And believe me, with AI, when we start talking of AI, we start with learning, then we come to Turing machines, when we come to fuzzy logics. Today, the most important part of AI is actually machine learning and deep learning, but we are also coming up with explainable AI. And even that explainable AI is also adding up to more, that is neuromorphic computing, which we can see, and even to quantum based deep learning machines that will come after 10 to 15 years. So this is one of the best applications that you can see. And even some people are also saying that Tesla has a good autonomous capability, but they still need to improve the model, because sometimes the car makes the brake, but sometimes the car don't make the brake. So still they need to master. And of course, Korea, Google, Korea is having one of the good area. Even I go to that park, and they have lots of dummies. They have a dummy city over there, and the people come over there to test their algorithms on the autonomous cars. This is the area where I'm working also, and you can see some of my applications, some of my papers and transactions on autonomous driving and vehicular ad hoc networks. And what I'm doing is that we can detect the weather conditions, and we know that if we go on a rainy season on this road, the car becomes slippery. If there is a snowfall, there is lots of problems on the road, so avoid that road. So my work is that how the autonomous vehicle detects the weather and how he makes the proper traveling salesman based optimized route calculation and makes the route better and better. So this is the area where I'm working. And if anybody is interested to work with me on autonomous vehicles, we are soon going to shift ourselves to autonomous drones. So the number one drone right now is Skydio, and we are working on the night-based flying of Skydio drone, which we will be starting in next 2 months for our research. So you can see the autonomous car sensors with the stereo cameras, the obstacle detection, the LiDARs, the radars, and of course the GPS. All this is mutually working because in autonomous vehicle, you are not the eyes. The eyes are the cameras, and of course the action is only done with the machine learning algorithms. So remember everybody, like you are the driver, your eyes are the focus on the road, and you take the action with your reflex axis, which means your body is only thing. But in the car, it is not like that. The camera takes the input and gives that input live to the feeds of the neural processing engine, and that neural processing engine takes the decision what action needs to be performed. If the road is open, the car speed up. If there is a vehicle, it makes the safe distance. But if there is a vehicle stoppage, it automatically stops. But we still need to improve it better and better. Still, I'm saying you as a scientist, everybody, I'm a computer scientist. Believe me, still the world needs to perfect it more. We are not ready for autonomous vehicles in next 3 or 4 years. Still, we need to wait. So this is what you can say the autonomous technology. And this is one of the cool areas where we are working right now, how we can path plan. And of course, how the cars are also learning from their drivers. And still we are into level 4 automation, where most of the driving can be done by the vehicle, but some of the driving needs the human beings. So with human beings, when it is using, so the machine is actually learning. That's why we don't explicitly program the machines. So in the headlines, you can see most of the fake headlines also come. And of course, you can know about the robot Sophie, which is automatically detecting the routes and the news and how it is programming with the news agencies and other things, because the data is really complex and there is a massive amount of data which is becoming scalable and flexible. And since we are entering into the era of digital age, which is a complete autonomous age, this type of deep learning and NLP needs to be perfected more. So this is one of the deep belief. You can see everybody that we have the image and we want to detect that whether this person is who. Like suppose if I make 100 samples of the image and this machine is getting the input label. So that input label, we have the CNN based different types of categories, and that pixels are getting into feature extraction. We get the edges, and of course with combination of edges, we put into the models, like whether the model is a regression model, SVM model, or different types of models. Because today, if we start discussing machine learning, we can take the whole day, but I will not be discussing into depth. So with this type of object models, we can detect that who is the person. Like suppose you go, because suppose if you want to open, I will be telling you some of the tools. So the best tool for this is even OpenCV. So it is even based on Python. And if you are really interested for a better, like a computer vision and other things, then there is a device called NVIDIA Jetson Nano, which you can buy. And there is also NVIDIA based computer vision based algorithms, which are even better than OpenCV. Okay, so you can buy that and you can do that. And OpenCV is even a library which is Python based. So you need to know the Python in order to do these type of operations. So this is what about the learning of object paths. And believe me, if you ask of the autonomous vehicles today, most of the programming is based on Python. And after that, it is based on TensorFlow. Some is using Keras, and some is even using the PyTorch and other things. So believe me, this type of images will be the better for you to understand that the machine has the input, machine needs the output also, but we need to train with the images hard and hard with the algorithms in order to get the results. So this is one of the scene labeling by deep learning. So you can see that if you talk of China, if you go on a camera on a road, They even detect who are you, what is your social security number, what is your face expression, and where you are coming from, where you are going. And of course, they can even detect with the face recognition also. So these are the multi-labeling scheme. And even you can see some of my papers we have even done with the fixed text. And even we have done some libraries that how we can go for multi-vehicle path tracking, license plate detection. We have done lots of research in this area. So this is one of the inference that you can see from the deep learning models. When we have the input images are actually known as the input, the data, and of course these images are also known as the output. And after that we put the samples using feed forward mechanisms or other models, and of course then we can come in front of the camera and we can understand that who is me. So similarly, if suppose I have a cataract in my eye, so whether which level of cataract I have or whether it's a diabetic retinopathy. So similarly, we have to train the system with the data, with the images. It knows the data, it knows tons of data. It has the output also. And once I cut in front of it and it takes my my photo from the computer vision with the camera. And of course, it can detect that whether you have the cataract or not. So this is the machine learning in speech processing. So you can see one of my latest books that is into digital signal processing of machine learning, one of the best books that you can see. And of course, it is used to predict the phone states, that whether you are angry, whether you are into tension, whether you are happy, what kind of things that you can do. So similarly, we have the feature extraction, and we put that image into, we put that input data into neural processing engine that decodes with the particular results. And of course, we have the explainable AI that can understand you are happy 80%, you are sad 5%, and neutral is only 15%. So similarly, you can make these answers and you can make the predictions. So this is one of the best papers that I have written, and you can see that paper online. So impact of deep learning on speech recognition. Even today, if I say like, hey, Google, book an appointment with my tailor at 5:30 and remind me at 5:15 that I have to leave there. It is a message for the Google, but actually I am accessing the reminder, I'm accessing the alarm, I'm doing lots of things over there. So similarly, even believe me, everybody, I am interacting with Siri so much that if I want to dial a number to my friend, I just don't say that, hey, Google, dial this. I just don't open my phone, unlock my phone and say, I just say, hey, Google, please call to my this friend. And of course, the number gets dialed and I'm putting on the speaker phone and I'm talking to that. I don't have to touch my phone even with this type of speech technology. Now, these are the type of learnings that you can see, everybody. The most important learning these days is unsupervised. If you're talking of drones, because you put the some type of learning, but of course with the outputs and of course with real time, they can keep on generating the data. So what is supervised, everybody? We give the data, we give the outputs. We are actually giving the results in terms of limited data. Unsupervised, we are training the data, but we don't know the outputs. We put it into the real world. And of course, like if we put 10 lakh images of diabetic retinopathy into the image, but we don't give any image as an input, we give the live human beings as a subject, and it detects that, okay, sir, your diabetic retinopathy is 80%. That's why we need to master the algorithms. So semi-supervised, we have the training data, but we have few outputs. And of course, with reinforcement learning, it is actually learning as per the actions. So this is one of the technique that you can see on supervised learning, that is regression. So given you that whether it is some type of input, you have a function that can predict the Y based on X. So the only thing is that you need to give so much of data that it is actually predicting better and better. So if you're into the start of machine learning, you can detect the pattern of flowers, that whether the flower is cherry or red flower or whether it's an orange flower. You can define and you can do the detection. So this is another classification area where we are working, that what kind of breast cancer. We are putting up some images of 9,85,000 images into the input. And of course, we can categorize that, okay, this is a type 1 cancer, this is the type 2 cancer, this is the type 3 cancer. And if a woman breast X-ray is given in the input, and immediately we can get the results. So this is one of the supervised, unsupervised learning where we don't know what will be the outcome. We just put the input data and we put the models, and rather than to wait for the more results over there for validation, we put that machine in real time. So drones, capturing of the drone, following of the path, return of the drone to the home. It is all based on unsupervised learning, because we can fly the drone in tons of environments, and we can even do the path planning of the drone, that okay sir, this is the point A, point C, point E, now go to point E, take the photos, take the videos, and come back. So the drone can even take Google Maps as image as an input, that okay, which photos I have to take and what kind of video I need to make, and then I have to return back home, and I have to take care of the battery also. So the drone is actually an autonomous system. It's a complete human being that is flying, taking the photos, returning back to the home. And this is one of the best areas that you can see right now. The most important unsupervised learning is with Facebook. So today, if I create the account with my photo, and if I add some friends, and I can keep on adding their photos and other things. So next time when I add the photo, it is automatically detecting my friends. So if you give the best answer for unsupervised learning, it is Facebook, the best example. And even if you talk of Twitters, when we go for the hashtag and other things, how we detect that, it is all like that. So this is one of the reinforcement learning, and we are using reinforcement learning in games. So we can give some state of actions, like what was the state and what was the action, and we give the output, and the machine acts into that, like game playing, robots. And of course, like if you talk of the maze game, and I think everybody knows about the movie called Maze Runner, where every day what was happening is that the people go in the maze, and after that they have to come, they need to predict that what pattern they need to follow when they have to come back, what pattern they have to go left and right to be avoid from those type of predators, and they have to come back out. Okay, so this is one of the reinforcement learning that you can see, everybody, that now today I'm happy to inform you that Mario was played up to 80%, but soon everybody, the latest Mario stages, that is a super kart Mario, me and my team is working day and night on this area, that we can play the super kart Mario on our iPhone, which can be not played by the human beings, but it can be played with the machines. So this is one of the practical example when the machine is given tons of these stages, that okay, how the Mario is being played, and after that machine keeps on learning, and he knows what to avoid, when to jump, when to fire. It automatically takes a decision and clears the stage. And believe me, the results are outstanding today. So this is also one of the policy that you can see, the autonomous helicopters, and of course the drones where we are working. So this will be like, okay. So ML is a nutshell. You can see that tons of thousands of machine learning algorithms are there. Hundreds news are coming. And of course, these days, we are not talking of ML and DL. We are talking of explainable AI. And every ML algorithm has three components. Remember that: representation, optimization, and evaluation. Representation is with the data, optimization is with the model, and evaluation with the validation of the real-time data. So with the evaluation, we can understand that how accurate is your model, is your algorithm. And of course, with optimization, the model keeps on learning. Representation means you keep on giving the data, and data. That's why the importance of data science is very important, very important. So various functional representations that you can see, everybody: numerical functions with linear regressions, neural networks, symbolic functions, decision trees, instance-based functions called nearest neighbor, and of course with probabilistic graphical models, we have naive Bayes, Bayesian networks, Markov models. We can even go on GANs, RCNN. We have tons of things today. Okay. And for the evaluation, you can do for accuracy, precision. So that's why if you are putting up your ML papers, you have seen that the results are in these type of states: accuracy, precision, and recall, the squared error, cost, margin, entropy, KL divergence. So it depends on you what kind of error you can generate, and you can do that. So the lessons that we have learned about machine learning, you can see that it is basically based on direct and indirect experience. Direct is from your side when you give the data set, and indirect will be the outside world. And of course, we have the function approximation when we make some types of hypothesis. What is the fitness set of a training data? And we go for keep on changing the models, and we keep on having different type of techniques. Believe me, my friend has even challenged me, can we play the casino, that how we can predict that what kind of numbers we can come. And even we are going to train the machine learning model with some of the casino games, and we can turn lots of, we can turn that casino machine into bucks making machine for us. So we are going to soon start our research on casinos based retro machines. So this is a brief history of machine learning that you can see from 1950, 60s, and 70s. But the most important accuracy came from 1960s when we have pattern recognition, 1970s expert system, which I will be discussing after 5 minutes when I will be telling about ML in medicine. And in 1980s, we have the breakthrough with the PAC learning theory, which is right now the basics of that, and of course with explainable based learning. And 1990, we have data mining, reinforcement learning, the text learning that is known as the NLP today. And from 2000s, we have our SVMs, we have our graphical models, robotics and visions. And in 2010 onwards, we all know deep learning, Bayesian models, multitasking, explainable AI, advanced neural networks, GANs. And still we can expect more and more things in the near future. So in a nutshell, you can see that this is the supervised learning, unsupervised learning, reinforcement learning. And our focus on my research focus is to apply machine learning to real-time applications. That's why we are designing robots, Internet of Medical Things. My research area into my lab is the design of the intelligent systems that is IoT and AI driven, which can be the center to solve the problems in real time and interact with the real time human beings to improve the data and improve the coordinations. So I will take your questions at the end of my lecture, but right now I will be moving towards my second part of the lecture today, in which I will be just giving you some aspects with regard to machine learning for healthcare. So everybody, let us take about history of AI and ML in healthcare. You can see in 1970s, we have the MySyn expert system when we have the user, which has the use case, and we have the interface. It has the inference engine, and this was actually deriving the result from the knowledge base, and we are getting the explanation. This was the first expert system with MySyn, and after that we know about eMySyn, Dendrine systems, and today we have the AI systems everywhere. If you even go to MATLAB, you just type fuzzy tipper, you can even do for fuzzy logics. And of course, today we are using TensorFlow, CNN, RCNN, GANs to make the expert systems. So in 1980s, we have the internist that you can see the clinicians enter the symptoms manually, and of course it is difficult to maintain. But nowadays we don't have to enter the symptoms. We all have the input, we have the training, we have everything. We just have to bring the patient in front of the machine, and we can do the predictions. Okay. So in 1990s, you can see the breakthrough came when the neural networks came, and of course with neural networks, the number of features. And of course, with the edge detection, we are able to perform lots of generalizations to new places. So why we need the now? Because the data. Now today, the world is becoming more and more connected. We have the data sets. We are more connected to the whole world. So that's the reason everybody today, data is everything. If you don't have the data, we have nothing. That's the reason I was collecting the data from tons of hospitals, online sources regarding the COVID-19 patients, the predictions and everything. But we know that even that data was not so accurate, but still we were able to build up the system, which is 70% accurate. So overall accuracy for COVID-19 has not touched 46% because that we were not having availability and access to the complete accurate data. That was the problem. So you can see this is the EHR, and if you search on EHR with my name, you will see the first EHR-based blockchain system was actually designed by me and my team. And believe me, the EHR has even improved, and with the electronic healthcare records, we are adding up more automations, and with chatbots, we are able to make most of the process possible without even intervention of the human beings. So this is one of the large data sets that you can see, which you can see the Mimic data set. And if you are interested, you can download it and you can use that. But of course, we have the Kaggle, we have the Google dataset search engine search, and that's all we have today. And these are some of the large data sets that you can see. We started from simple data set with 40,000 patients, and now we have 230 million patients patterns. Now that's the reason, everybody, that we are actually after cloud. We are putting up whole of the data on the cloud, which is scalable. And we are even using some NVIDIA clouds to actually scale up the computing with the advanced data centers, and we are getting the results. So believe me, by the next 3 or 4 months, we will not do any machine learning coding on our computers. We will only use our computers to program everything on the cloud. Rest whole the infrastructure and the results will be given to us only, but infrastructure will be available on the cloud only. So this is the diversity of healthcare center, everybody. What kind of devices that you use, the phones, the lab testing, imaging, genomics, and we are working on every area. If you are interested, you are most welcome to send me your CV for your postdocs and PhDs, which we are actually taking up for AI in healthcare only. And why now algorithms, you can see that we have improved the machine learning advancements with semi-supervised and unsupervised learning. And we have these type of open source softwares, which are all free. That is the Python scikit-learn, which is very important, Thenio, TensorFlow, Torch, we have everything. So if you are really interested, just go for this type of TensorFlow. You can even go for Keras, the NumPy, the SciPy, and of course, scikit-learn, matplotlib. You can name the libraries. I can talk on these libraries the whole day. So this is what of the industry interest where IBM Watson is there, but we are actually using Amazon AWS, and we are even having machine learning over there, but we don't prefer Azure right now. So these are some of the examples that you can see. The emergency department, we can even have the data in emergency department when we are getting information in the form of text. We are actually putting up that data in the form of digital, that is the business intelligence. And we are having the consultants, we are getting the X-rays, we are putting up into the AI systems, and we are getting the results. And of course, we have the lots of clinical pathways. I have already told you lots of movies like Spider-Man. They're even saying, how about the genome sequencing, synthetic biology? And of course, we have the neuromorphic processes that can take up the robotic surgeries in the near future. And yeah, so we can even improve the documentation that you can see that how the machines are actually taking up the data. Now, even today, there are some libraries you just have to type whatever you need and you just play and you just run that library. It will automatically generate code for you. Like suppose if I give lots of data set from the airport and I just say, generate the query that I want to know which flights were delayed on this day from this time to this time. You just press enter, it gives the data and it will also generate the code also for you. No need to even type the code also. Everything is becoming autonomous and of course, intelligent. So this would be my last topic. So what about unique? You can see that life or death decisions, we need robust algorithms. We require more fair and accountable algorithms. The naive use of supervised learning is becoming inefficient. That's the reason COVID-19 was actually failing in terms of AI. So these are some of the public data sets that you can see, everybody. The Mimic, the PhysioNet data set. Of course, the researcher.the MMRF, the multi-myelomia, if you want to research, but the data sets are very small, but you need to add more data sets that you can find from Kaggle. The Parkinson disease, the mammography, of course, the pathology disease that you can see right now. And we have the lung cancer and diabetic retinopathy. This is the major areas I'm working. And now if you have any questions, please let me know. This will be my lecture. Hope today with this lecture, you have got a great idea that what exactly is machine learning, what exactly are the opportunities, what exactly is the application area. But I can even talk on machine learning for robotics, for even for that is the underwater sensor communications. We have tons of projects with us from ASEAN, even from Korea, National Science Fund. Even I'm having 2 projects of Australian Research Council where we're working for Industry 5.0 and cyber physical systems with AI. So I can talk on these things much and much. But because of limitations of time, I cannot extend my lecture for more time, but I will give you more time for your lecture, for your questions. So please now unmute yourself, or if you have a question, you can type it on the chat box. You are most welcome for your questions.
Good morning, sir.
Good morning.
Sir, there is apprehension that machine learning is going to replace the computing systems, computers in the days to come. Is it true?
First of all, I would like to tell you that actually your question is not fully correct and it is not fully complete. So let me first of all complete your question and give you the robotics replace the humans. It is not. Actually, the word robot don't exist. Actually, the word is called cobot. Cobot means collaborative botics, when robot and the human beings, they combine together in a collaboration and they keep on working. Now, coming to your question, that can the machine learning machines can be replacing the other things? It will not be replacing. Actually, the technology and the portfolio for real-time applications will be changing. Like suppose at one time, because even I'm working with lots of surgeons. At one time, they were only using machine learning and some simple camera phones and other things. But today we are actually improving that technology with HoloLens 2, and of course with Oculus Rift. Now today, let me tell you, if you can understand me, what I'm doing with a dentist like that, like suppose I am going on a road and I met with an accident and I get a problem with the teeth, like here and here. Now, rather than dentist works on me and gives me the final shape, he or she makes the digital twin of mine, like a simulation. It performs the surgery on the digital twin and the machine will tell that, okay, sir, you were wrong here, you were accurate here, you can improve like this. Then it will come to me, my operation will be better and better. So the answer is only the machines and the technologies will change, but the base ground and of course the learning experience and the algorithms, the mathematics, that will be improving. That's the answer. You got it?
Thank you, sir.
Thank you.
Thank you so much, sir, for sharing your knowledgeable information with us.
Okay, let me share some more detail. Okay,
Yes.
let me. Can you please give me the sharing result, please? Sharing
Yes.
screen. Okay. Okay. So everyone, if you can go to Google, you just type my name. You can find my name and you can find my search on Google. And if you want to see my research, you can see on Google Scholar, and you can see my citations crossing above 5,500 almost. And if you want to type more on machine learning, you can go on there, scholar.google. And if you just search machine learning and just type my name, let me show you something. This is one of the best cited paper in the world with 200 plus citations, machine learning from theory to algorithms. If even a school going student wants to learn about machine learning, you download this paper and start learning. It contains everything, and rest you can see everything with regard to my COVID-19 and other areas that I've worked. And if you want to see more of my book, that is the machine learning handbook, just search this with my name. It is from IJ Global. You can see, everybody, this is one of the biggest book that you can see ever written in the history of machine learning. Nobody has broken my record of more than 2,400 pages of this book. Nobody will broke this record. Nobody will. And of course, recently we have done some book on this one, that is machine learning and signal processing. And you can go and use this book also. This is one of the best books that you can see in signal processing for machine learning. No scientist and no author has written any book on signal processing with machine learning till date. This is one of the best books that you can see, the best of its class. Okay. And if you want to follow me on Instagram, you can follow me. Okay. And if you want to email me, you can email me over here. Let me show you. Okay. Let me give you the contact details. So here is my email address, everybody. So thank you so much. If there is any question, you are most welcome to give me the question on my email. I will be more than happy to help you out for that. That's all, ma'am. That's all from my side.
Thank you so much, sir. So please accept our token of appreciation from CIR.
Thank you so much.
Now I would like to request Dr. Sanjay Mishra, Professor, Department of Computer and Science, Information Sciences, Convent University, Nigeria, to deliver the keynote address. Dr. Sanjay Mishra is full professor of computer engineering at Convent University, OTA, Nigeria. He has 25 years of wide experience in academic and administration and research in various universities in Asia, Europe, and Africa. He is PhD in Information and Knowledge from University of Alcalá, Spain, and MTech from Motilal Nehru National Institute of Technology, India. He has authored and co-authored in around 300 papers. Majority of publications are in ISI, Web of Science, and got several awards for outstanding publication. He has delivered 41 plenary and keynote speeches and 40 invited talks in various universities and institutions around the world. He is the editor-chief of the book series Advancing IT Personals and Project Management. author of one book, and founder chair of 3 annual international workshops. His current research covered the areas of software quality assurance, object-oriented technologies, SOA, web service, artificial intelligence, neural network, health informatics, e-learning, cloud computing, and cybersecurity. So now you can take it forward from here.
Thank you so much, Amisha. Can you hear me?
Yes, sir.
Yeah, good morning, everybody. So I think my time is already gone. It was the allotted time was exactly from 11 to 11:30, right, or something, and it's okay. Let us start because I have to go to the office as well. I'm sharing the screen. Please enable me to share the screen and let us go and talk as soon as possible.
Yes.
First of all, thank you so much, all the conference organizer, and for giving me this opportunity. Let us see and discuss. I will give you some of the area of the research in means machine learning and blockchain. Is it still unable to share? You have already disabled me participate screen sharing. Please allow me to share the screen.
Yes, sir. Yeah.
So we will talk a bit. Hope that all the participants enjoyed a lot. You are the host now. Now I think I can. So I hope that it is now on the screen, right?
Yes, sir.
Yes, the first thing is that now I'm in the Oxford University College in Norway, Halden, Norway, not in Nigeria. I came last year. I don't know that my old CV was there. Let it come out. So we really enjoyed the last lecture. You have some practical implications, and you will see some of the more area of the research related to the blockchain and machine learning. Let it come out. I don't know what is happening due to the I'm not closing. Yes, I think it is on, right? The integration of machine learning methods with the blockchain technology. So it is more on the review, and you can see a lot of what the researches are going on. We all know that in these days, blockchain technology and bitcoins and all those steps how much they are coming up. So machine learning and blockchains are the two of the most notable technologies in the recent years. And both technologies are the data driven, and thus there are rapidly growing interest in integrating both for the more secure and efficient.
Sorry to interrupt, sir. Your screen is not visible.
My screen is not visible?
Yes, sir. Your screen is not visible.
Okay, I'm again sharing.
Yes.
I'm again sharing. Is it now?
Yes, sir. Yes.
So, okay, I'm not doing it with a full screen. Maybe it is one of the issue because it is coming up.
Yes, sir.
Is it coming up? Can you see?
Yes, sir. It is visible.
Let it come, but I can't see now. Internet is very good here. Everything is right. I don't know what is maybe the bandwidth problem at the other end. The previous lecture was very nice. So what is the basic problem, in fact, behind it in these days? Can you see it now?
Yes, sir.
In the full screen, yes. The basic problem is that means how to utilize the machine learning algorithm and AI for securing the data transactions and other things. Being here, if you want to transfer the money all over the world to give anybody to any money, so instead of going to the bank and just to transfer your amount from here and there, these cryptocurrencies, Bitcoin, they are becoming very popular. In fact, even like Africa, it is very, very common to, if they want to send the money from Africa to the Canada, they just to go, they purchase the Bitcoins and just to tell some of the numbers, and in Canada or anywhere in the world,
they are going to again sell it and they will get the money. So this is all about what is happening in these days. So blockchain is the secure, decentralized ledger that underlies the cryptocurrencies like Bitcoin and the future infrastructure for distributed computing with the consensus to the state. From a white papers that describes how the Bitcoin cryptocurrency could be constructed. I have given all those references. So in a particular area, if you are interested, just to go there and take that particular paper to go into the deep of a particular area. So the blockchain technology, which is a list of concerned blocks, which contains a hash, a link to the previous block, a timestamp, and a transaction data. So ML is used in a wide range of applications like daily life activities. We all know, we all heard, listen to the lecture of the Dr. Anand, financial, banking, healthcare, transportation, almost everywhere. So recent news predicts that by the end of the 2030, AI will reach the $30 trillion in the value. So the integration of machine learning and blockchain is estimated to have various advantages and benefits. It provides a secure, trusted, and distributed platform for sharing the huge volumes of the data for the purpose of analysis, learning, and decision-making between the parties without the need to the central authority or the intermediaries. So blockchain ability to guarantee the accuracy of the data makes it useful for feeding data into the AI systems and recording results from them. So see this figure, it will be more clear what are the components of the blockchain. This is the building block of the blockchain. There is a block, there is a hash function, there is a ledger, there is a consensus mechanism, there is a transaction, there is a miner. So this is the building block. So what are the features? The blockchain shares are common features that involve the decentralizations, transparency, immutability, better security, anonymity, cost reduction, and autonomy. So how we are going to see that when AI or the machine learning is going to merge with the blockchain, what are the advantages, what are the disadvantages, and how we are going to prove all these existing problems. So you can see that there is a various type of the blockchains, public blockchains, private blockchain, and consortium blockchain. So high-level authentic blockchain, you can see from a paper from 2021, ledger, the chain of the blocks, confidentiality, transparency, cryptology, and smart contracts. So what are the key aspects needed to enable the trust in the AI, the reuse of the model, the reuse of the models, AI assets, confidentiality sharing, auditability, verification, assurance, attestations of the results and the AI process, provenance, traceability of the ownership, uses, fairness, and bias. So these are the things what we need to merge with the blockchain with the AI and the machine learning. What are the design principles which supports for a variety of the AI scenarios and the workloads, support for a varieties of the organization setting, different varying granularity. So if you see that how the blockchain technology can benefit the ML, so on the left hand side you can see the features of the blockchain, and on the right hand side you can see the benefits of the machine learning. The feature of the blockchain is the shared, transparent, and distributed ledger, immutable, irreversible, and auditable record. In the benefits of the machine learning is the data and model sharing. Again, in blockchain, decentralized P2P communication, cryptographical, secure digital ledger. In machine learning, security and privacy, decentralized intelligence. Again, in the blockchain, sequential and timestamp, consensus-based updating, and in the machine learning, trust for the decision making. So you can see that how we can see that what are the features of the blockchain, features of the machine learning, how we are going to integrate it. So integration of machine learning with the blockchain, we will give the sentiment analysis. I mentioned you earlier that this is a vast area and it depends on a particular field in which you wish to go to work on that one. So there are several works out there for the price predictions. Then you are combining to the machine learning to the blockchain technology. Social media, there are some works, healthcare industry. So when you are combining them, you can see a lot of applications. The learning capabilities of ML can be applied to blockchain-based applications to make them smarter by using the ML security of the distributed ledger may be improved. Machine learning may also be used to enhance the time taken to reach the consensus by building the better data sharing routes. Further, it creates an opportunity to build better models by taking the advantage of the decentralized architecture of the blockchain. So a few of the benefits are listed when the ML machine learning is applied to the blockchain. User authentication as a legitimate user. Blockchain technology provides a high level of security and trust. Blockchain integrates public ML models into the smart contracts. Blockchain technology also helps in reliable implementation of an incentive-based system. Also, these ML models can be updated on chain environment of the blockchain with a small fee and off-chain. Good data contributions can happen from users and customers. Tamper-proof smart contracts can be evaluated by the different machines. Payment process in the real time with the trust on a blockchain environment. Blockchain tools, for instance, Ethereum deal with the thousands of the decentralized machines all over the world. What is the decentralized machine learning? The concept of decentralized machine learning has been recently emerging, which decentralized AI is basically a combination of AI and blockchain. So this is what the researches are going on when you are combining to the machine learning and blockchain. The decentralized AI enables to process and perform analytics or the decision making on trusted, digitally signed and the secured shared data that has been transacted and is stored on the blockchain in a distributed and decentralized fashion without trusted third parties or the intermediaries. The feature of blockchain is smart contracts give the ability to program the blockchain to govern the transactions among participants involved in the decision making or the generating and assessing the data. AI techniques that utilize the blockchain can offer the decentralized learning to facilitate a trust and secure sharing of knowledge and decision outcomes across a large number of autonomous agents, which can contribute, coordinate, and vote on further decision. So if you see that this is the latest trend in AI application and benefit of using the blockchain, you also heard in the previous lecture that explainable AI, we are not talking about the AI. This is a past thing now. So explainable AI, designing the trustworthy and interpretable, transparent AI algorithm to know why the algorithm is reaching a specific decision. So this is the objective application in several areas, healthcare, military, autonomous vehicles, and the blockchain benefit is when we are combining them, the trust, tracing, execution reliability. In fact, you will find one of our papers, we are doing a review, a systematic literature review on the explainable AI and the blockchain technology. Digital twins. This is another new area which is translating the data and intelligence from the complex physical systems into the application and simulations in the digital world. So the application is in the wind turbines, aircrafts, engines, offshore vessels, and blockchain benefit is again the trust, provenance, and the reliability. Automated machine learning. We are all observing in these days that what is happening in with the automated machine learning. Similarly, the hybrid learning, it is also by Lu et al. In 2018, combining the different machine learning models to reach the better informed decisions. And if you see these applications in real-time diagnosis, decision diagnosis, data source diagnosis, and from the blockchain, again, we are getting the benefits that are trust, provenance, and performance. Also in the lean and augmented data learning, this is also a new area. You can find a paper of the Peng et al. But the enabling transfer learning among the different AI applications to ensure high availability of relevant and accurate data. That is the low data availability applications where it can be applied. And again, the same features of the blockchains if you are merging with AI. So these are the things what you what you can find the latest technologies. So these are some of the latest studies in the integration of blockchain and ML. Various type of AI applications are known as classification, prediction, decision makings, and optimization. Also, blockchain is known as secure, centralized, secure distributed ledger that can be used in trading ecosystems. We divided all studies into the specific categories. So you can find the classification of the clustering. Several papers are there. Distributed management. There's several papers are there. Improve security or the efficiency. You can find several works there, and you can also find the prediction or the decision making. All those papers are there. So what are the key features and benefit of the blockchain integration with the AI? In the blockchain, we have this property of the decentralized, deterministic, immutable, data integrity, attack license, and in AI, which is centralized, changing, probabilistic, volatile, data knowledge, and decision centric. So when we are integrating, we are finding the enhanced data security, improved trust on the robotic system, collective decision making, decentralized intelligence, and high efficiency. So when we are using in the blockchain technology, there are several issues and challenges in the blockchain, such as security and performance that can be addressed by applying the AI techniques. We are coming to the conclusion how this can be merged to increase the security of blockchain-based healthcare applications, machine learning applications. Machine learning predictions is used to detect unknown root exploit. Furthermore, the supervised machine learning algorithm can detect and stop the majority attacks or anomaly behaviors in the blockchain networks. AI can also be used to manage the blockchain and improve its performance. Predicting the Bitcoin pricing process has also been done using the machine learning techniques. Based on the behavior pattern analysis, Bitcoin addresses can be classified, and each cluster is controlled by the same user. So what are the major concerns at this time? Even though the blockchain has a lot of offers and can help a lot of technology by adding some value, there are still some concern about it, and they are the security, anonymity, and privacy and abuse of the blockchain. How it is AI is blockchain for the AI, that is the secure data sharing and marketplace for the AI, decentralized computing for the AI, explainable AI, which is the new areas coordinating the untrusted devices. That was the blockchain for AI and AI for the blockchain. How can they just to complement to each other? Secure and scalable blockchains, privacy presenting personalizations, and automatic referee and the governments. So what are the challenges with the blockchain technology with the AI? Those are the security and privacy, deterministic execution and smart contracts vulnerabilities, and emerging consensus AI specific protocols, governance and regulations, side chain and scalability, fog and quantum computing badges. These are the challenges. And in conclusion of this lecture, this presentation has focused on studies that use the machine learning algorithm or the artificial intelligence to add the intelligence to the application, and at the same time used blockchain as a hyperledger to add the automations, security, and truth. So distributed management, security, and efficiency, improvement, predictions, and decision makings are the most popular type of the applications. So blockchain governed by the machine learning algorithms can detect and prevent attacks and improve security and privacy in different applications. It also shows that integrated features of the AI and blockchain can play an important role in the medical field, including various stages such as gathering, analytics, and decision making on the healthcare data set. So in future studies, the convergence of the blockchain and AI can provide lots of the innovations to improve the human life. However, it is still in the first of the row, and there are many research challenges to be addressed. That is the scalability, lack of the standard issues in consensus protocols, etc. It is a great opportunity for future research to be conducted in this area. I hope that in a short, I gave a lot of things where AI and machine learning algorithms are merging to the blockchain technology. And these are all the references which we have used in this one. In fact, this is the part of one of our papers which we have written, so you can find all those. I try to give you a lot of works inside this presentation that in a particular area, because this is a research presentation, and when you talk about the research presentation, you have to give an opportunity to the listener that in a particular area in which you are interested, then you can go to do particular paper and then see that what is happening and what is remaining, and then particular focus on that area. I hope that in a 30 minutes talk, I exactly spend the 20 minutes and 10 minutes for you can take for some of the questions and answer. So for the time management, this is my presentations. Hope you enjoyed. Thank you so much.
Thank you so much, sir.
Yes,
Please
Amisha,
accept
from the
our token of
audience, you have any
appreciation.
questions,
Yes, sir.
please?
Oh, yeah.
I don't want to make the delay of the next program because already we are running late, right?
Yes.
For half an hour.
So please accept our token of appreciation.
Thank you so much. Okay, thank you for the invitation. And I request to the organizer that you can also collect the presentations and just to upload on the website if any of the audience they want to see or something, and share the link to all the audience that all those references what we are talking about or what we are going to give us, it will be available to all the participants. It will be better for everybody, yes, right?
Thank you so much, sir.
So send me email, I will send you my PPT exactly in the same way you can ask to all the speakers.
Yes.
Anything else?
Sir, like,
it's okay. Thank you so much.
thank you so much, sir.
Okay. So can I leave now?
Yes, sir.
I have to go to the office. Otherwise, I love to be here to listen more and more, right? Thank you so much.
Now, Dr. Sohi Kekai, Assistant Professor, Department of Computer Science and Engineering, Nagoya Institute of Technology, is going to address the gathering. Here, I would like to add Dr. Yoshika, Associate Professor, Graduate School of Engineering, Kobe University, Japan, associated with Kekai in the presentation. Dr. Kekai has received the BA degree and MA degree from Gifu University, Japan in 2011 and 2013 respectively, and the PhD degree from Kobe University, Japan in 2019. He has been an assistant professor with the Department of Computer Science and Engineering, Nagoya Institute of Japan since 2019. His current research interests include blockchain technology and information security. He is a member of IEICE and IPSJ. And also introducing Dr. Yoshiki, he had received the BA and MA degree from Aimiya University, Japan in 1995 and 1997 respectively, and the PhD degree from University of Tokushima, Japan in 2000. Since 2013, he has been an associate professor with the Department of Electronic and Electronic Engineering, Kobe University, Japan. His current research interests include information security, cryptography, computer networks, and knowledge sharing and creation support. He is a member of ACM and senior member of IEICE and IPSG. Let's hear Dr. Sohi Kekai.
Hello, my name is Shohei Kakei. Today, I'd like to talk about the work with Professor Shiraishi. The title is Distributed Ledger Technology, Authentication and Authorization, Meta-PKI, and Cross-Domain Authorization. In this theme, we are going to consider how DLT can contribute to improving the security of PKIs. Lastly, I will describe cross-domain authorization. In this theme, we are going to consider how DLT can contribute to improving the security of authorization frameworks used on the web. DLT enables the operation and use of distributed ledgers. A distributed ledger is a ledger that is shared among multiple nodes, and only data that is determined to be appropriate by a consensus algorithm is synchronized among the nodes. The ledger is a data store that stores transactions, which are records of purchase events, in an unalterable form. When a user wants to write some data in the ledger, only those agreed upon by the consensus algorithm are reflected in the ledger. There's not just one ledger, but multiple interconnected ledgers, which together are called a distributed ledger. A distributed ledger consists of multiple nodes, which are managed and operated by a specific community. There are two types of community: permissionless DLT, which allows free participation, and permissioned DLT, which allows participation only by authorized entities. One of the most notable features of distributed ledgers is smart contracts. Smart contracts are computer programs installed on the DLT system that can process data in the distributed ledger and write the processing results to the distributed ledger. When a user requests the execution of a smart contract, it reads data from the ledger and processes the data. The processing result is then created as a transaction, and this transaction is organized into a data structure called a block. Lastly, the transactions are reflected in the distributed ledger in units of blocks through the consensus algorithm. Focusing on the relationship between users, smart contracts, and distributed ledgers, it can be seen that smart contracts act as an interface to the distributed ledger and can restrict free reads and writes to data in the distributed ledger. This feature has the effect of limiting data manipulation. Hyperledger Fabric is a well-known open-source DLT. It's a permissioned DLT that has a number of use cases in enterprise-oriented areas, such as supply chain and finance. In Hyperledger Fabric, as key value store, and smart contracts can be written in Go, Java, or Node.js. The consensus algorithm uses endorsement ordering validation. Endorsement is to collect signatures for transactions from a default number of nodes. Ordering is to determine the order in which transactions are reflected in the distributed ledger. Validation is to verify whether there are no problems with no endorsement in each node. We are using Hyperledger Fabric in the two research themes described today. That's all about an overview of DLT. Next, I'll explain MetaPKI. There is a challenge and response method as one of the authentication techniques using the digital signature. The digital signature can be used to verify that the peer has a signing key corresponding to the verification key. As shown in blue, if user A sends a string, the peer signs it, and the user verifies the signature. User A knows that the peer has a signing key corresponding to the verification key. However, the assurance that the peer is a server X is out of scope for digital signature. PKIs are known as mechanisms to guarantee the ownership of verification keys. A CA issues a digital certificate that guarantees the owner of the verification key. As shown in green, Server X obtains a certificate corresponding to its own verification key from the CA in advance. By sending this certificate to user A can verify the owner of the verification key. One of the open issues in PKI is a single trust point of CA. For example, when server X requests a certificate, the CA creates an unsigned certificate based on the request and signs it with the CA's signing key. In this way, the CA guarantees which server owns which verification key. In other words, the guarantee by the CA is made with the CA's signing key. If an attacker can steal and abuse the CA signing key, he can act as a CA and create a certificate. In this case, the user cannot detect the fraudulent certificate because both certificates are signed with the signature key of the trusted CA. Another issue is the concentration of trust in root CA. A CA issues certificates, but it is impractical for a single CA to issue all certificates. Multiple CAs are actually connected in a hierarchical structure. In this structure, the root CA issues a certificate to CA3, and CA3 issues a certificate to server X. The user only needs to trust the root CA. By following the link from server X certificate to the root CA's certificate, he can conclude the server X certificate is trustworthy. This is an advantage of the concentration trust, but on the other hand, if CA's signing key is compromised, the attacker can impersonate CA2 or CA3 or servers under these CAs. As shown in the figure on the left, on the Internet, each CA registers its certificates in the database of trusted certificates developed by the browser vendors. Then these certificates are installed in the browser as a trusted certificate list. In this way, the browser can trust servers that have certificates from the CAs in the list. On the Internet, PKI security is maintained by a circle of trust among the browser vendors and CA operating organizations. However, the system of trusting multiple certificates altogether carries the risk that the compromise of one CA can spread to the entire system. For example, an attacker could trick user A by simply compromising a subset of these CAs. This problem is expected to become more prominent as the distribution of certificates expands with the spread of IoT and other technologies. Therefore, we believe it is necessary to devise a mechanism for certificate management that solves the problem of the conventional model of trusting multiple certificates altogether. Looking at the current PKI framework, there is a mechanism called cross-certification. Cross-certification can build a mesh PKI which does not specify a root CA like a hierarchical PKI. For example, in the case of certification between CA1 and CA2, CA1 will issue a certificate if it determines that CA2 is trustworthy, and the opposite is done in the same way. In the case of cross-certification, the user chooses a CA that they trust, and then trusts the server by following the mesh peak structure. In this research, we focus on a method for automating cross-certification. In cross-certification, a certificate is issued to the other CA. Challenges are how to measure the trustworthiness of the other CA and how to share the mesh structure across CAs. Manual operation by human will cause the vulnerabilities as the conventional PKI, and if a database operated by some organization is used, that database will become a single point of failure. Therefore, we propose a cross-certification framework for building a mesh PKI based on uniform standards using DLT. The figure shows an overview of MetaKey PKI. In this system, a MetaCA layer is added on top of the existing PKI layer. Its new layer is built on DLT, and each MetaCA corresponds to a node in the DLT network. The DLT network deploys smart contracts to manage MetaPKI. For example, participation transactions for joining the DLT network and construction transactions for performing cross-certification are deployed. Smart contracts use mechanically calculated scores from pre-declared policies to determine automatically if the cross-certification process is possible or not. In MetaPKI, declarable items and score values for each item are defined in advance as policy specifications. These parameters are stored in the distributed ledger for each CA. This information is used for calculating the score. In this example, it's defined that SHA-256 with RSA as a available signature algorithm is a score of 0.8, and 90 days as a validity period is a score of 1.0. Meta-CAs declare own certificate policy when they join the DLT network. In this example, Meta-CAX and Meta-CAY declare these policies. When performing cross-certification, the smart contract calculates a score based on the certificate policy and policy specification and decides whether a cross-certification can be performed according to that score. In this research, as a simple method, we make it a rule to perform a cross-certification if the meta-CA score of the other party is higher. However, smart contracts allow detailed decisions. In this way, certificate of policy declarations and score calculations by smart contracts allow the measurement of the trustworthiness of the other CA. Also, recording of the fact that the cross-certification has been performed in the distributed ledger allows the sharing of the measure structure across CAs. Now let me summarize research theme 1. In the existing PKI, multiple CAs are trusted altogether, so if only a few CAs are compromised, its effects could risk spreading to the entire PKI. Cross-certification can be used as a method of not trusting multiple CAs altogether, but it's a challenge for each CA to be able to perform cross-certification based on uniform standards. In this study, we proposed MetaPKI using DLT. MetaPKI securely stores CA information in a distributed ledger and shares it among the CAs. Then the logic for cross-certification using this information is implemented in the smart contract. Lastly, as a future work, we are considering a mechanism that incorporates the behavior of the CA rather than just the declaration of the CA. That's all about the PKI. Next, let me explain cross-domain authorization. The availability of the Internet as social infrastructure is increasing due to the expansion of functionalities through such as SNS and cloud systems, and the increase in Internet-connected devices such as smartphones and IoT. With this background, the type and amount of data that can be acquired are increasing. The Internet does not interconnect every device, but rather interconnects devices in units of various social activities such as organizations, industry groups, and services. In this presentation, I will refer to this unit of social activities as a domain. The challenge is to overcome this domain barrier in order to utilize the variety of data that exists on the Internet. Federated learning has attracted attention as a way to train machine learning models without directly sharing data. The central domain that wishes to gain insight from the data provides each domain with an initial model, and each domain trains its model. The central domain then gathers model updated information, which is the difference between the initial model and the trained model. Lastly, the central domain generates the final trained model using the gathered information. Since data is not directly exchanged, privacy is mitigated. However, this method of federation among multiple domains tends to aggregate insights in the central domain because it excludes other domains. This research aims to improve the diversity of data federation by providing disaggregated model update information to third parties. If the destination domain is determined at the discretion of the central domain, there is a risk that the cooperation of each domain in federated learning will be inhibited. UMA can be used to access resources across domains and can allow the resource owner to grant access to the resource to another user the requesting party. In the federated learning example, the resource here is a model update information. There are two notable features of UMA. The first is the ability to set policy conditions that control resource access. Based on the policy conditions, the authorization server can control accessing to resources. Second, communication specifications between the resource server and authorization server have been standardized. UMA defines endpoints called Protection API, which allows the resource server to communicate resource information to the authorization server. This standardization has made it possible for various resource servers and authorization servers to work together. The process flow is as follows. First, when the client requests a resource from the resource server, the resource server obtains a permission ticket from the authorization server and issues it to the client. The authorization server stores the permission ticket together with requested resource information. Next, the client requests the requesting party to collect claims, and the requesting party collects them from an external server informed by the authorization server and provides them to the client. The client presents the permission ticket and the claims to the authorization server, which issues a requesting party token to the client if the claim meets the policy conditions. Finally, the client requests the resource from the resource server using the requesting party token, and if there are no problems with it, the resource is provided to the client. From the above, UMA can allow to delegate access rights across parties and to authorization access to resources across domains. Since UMA can provide resources across parties and domains, it's a technology that meets the objectives of this study. For example, as shown in the figure, a resource owner can control providing data across various domains by simply setting policy conditions on the authorization server. Looking at the UMA mechanism from the authorization server's perspective, the authorization server is a single trust point. Therefore, if the authorization server fails, the access control mechanism will malfunction. Also, the authorization process performed by the authorization server is not transparent, and there is no guarantee that the authorization server will not perform unauthorized access control. Therefore, we need to eliminate the single trust point for the authorization server. In this research, to eliminate the single trust point of the authorization server, we realize the function of the authorization server with DLT. Issuance of tokens cannot be done at the discretion of each node, but must be based on a common decision based on the data in the distributed ledger. Therefore, the policy conditions, token issuance states, and resource information are managed in the distributed ledger, and the logic of token issuance is realized by smart contracts. In this research, these functions are realized with reference to the Protection API defined in the UMA specification. In this way, by sharing the data and logic handled by the authorization server among the nodes in the DLT network, the authorization server's single trust point is eliminated because it functions properly as a whole, even if some nodes are fraudulent. The figure shows the configuration of the proposed system. The authorization server has been replaced with the authorization blockchain, but the others are as specified in the UMA. The difference is that the protection API functions are implemented in smart contracts, and the information of the authorization process is managed in a distributed ledger. Since the authorization process is guaranteed to be executed by the smart contract, arbitrary authorization processes are treated as an invalid process. Additionally, since the data and logic are shared using DLT, communication in the authorization processes does not need to be limited to the same node, and failure that occurs on a node does not affect the entire system. Furthermore, it's possible to improve the transparency of the authorization process by auditing the distributed ledger to check for protocol deviations. The above figure shows the relationship between the main data handled by the proposed system. Resource owner guarantees the relationship between resource scopes, resource ID, and policy conditions. In the authorization process, the permission ticket is associated with requested scopes, requested resource ID, and claims, and it's verified that these have appropriate relationships with the resource scopes, the resource ID, and the policy conditions, respectively. Once these associations are confirmed, the requesting party token is issued. Most of the main data handled by the proposed system are verified and associated in the authorization blockchain. The proposed system can perform these processes transparently. Now let me summarize research theme 2. The use case for federated learning can be expanded if model update information can be provided to other domains at the intent of each domain by using UMA. However, the authorization process is not transparent and vulnerable to attack because the authorization server is a single trust point. Therefore, we propose a cross-domain authorization system using distributed ledger technology, and the proposed system token information is securely stored in a distributed ledger and shared among the nodes of the DLT network. The authorization process using this information is implemented in a smart contract, thereby eliminating the single trust point of the authorization server. Finally, for future work, the authorization system handles privacy information about who wants to access which data. Therefore, we are considering a privacy protection method that keeps such information secret from each node. In this presentation, I explained the DLT overview and our two research themes, MetaPKI and cross-domain authorization. The benefits of DLT is that it allows data to be unique while limiting the manipulation of each piece of data. MetaPKI uses DLT as a framework for interconnecting CAs with cross-certification. DLT can build the mechanism of cross-certification based on uniform standards and can build the PKI system that does not trust CAs altogether. Another research theme uses DLT for cross-domain authorization. DLT can eliminate the need to trust a single authorization server and improves transparency of the authorization process. Thanks for watching my presentation. Thank you for my
Thank you.
presentation. Please ask any questions.
Yes, I would like to request the audience if you have any question, please ask. I guess there is no more questions. Thank you, sir. Please accept our token of appreciation.
Thank you very much.
Now I would request Dr. Putro Suzuki, Professor, Department of Computer Science and Engineering, Toshiya University, Japan, to address the gathering. Dr. Suzuki is working as a professor in Department of Information and Intelligent Engineering at Toshiya University of Technology, Japan. He got his master's degree and PhD degree in mathematical science from the University of Tokyo. He has a number of patents and research publications to his credit. He is a member of IEICE, the Information Processing Society of Japan. His area research is cryptography and information security. Over to you, sir.
Okay. Thank you. Thank you for introducing me. So I would like to share my slide.
Yes, sir, you can.
Okay. Do you see my slide? Okay.
Yes.
I will start. Okay. The title of my talk is do you see the slide? Okay.
No, sir, it is not.
Okay. Okay, maybe you can see the slide. Okay,
Yes.
the title of my talk is Traceable Signature and its application to anonymous cryptocurrency. And I am Kotaro Suzuki, and this work is done with my co-author, Professor Ichiro Fujisaki, GEAST in Japan. And I am from Toyohashi University of Tech in Japan. Okay, so this is my bio. I obtained PhD degree from Tokyo University, and I was with NTT Laboratory, communication company, and now I'm in Toyohashi University of Technology. And this is agenda of this talk. I will talk about blockchain and cryptocurrency and anonymous cryptocurrency using traceable signature. So blockchain is a kind of bulletin board implemented in decentralized manner using proof of work, invented by Satoshi Nakamoto, as you know. In cryptocurrency, for example, Bitcoin, transaction data and signature is put on blockchain to be published and unmodifiable and to be unmodifiable. However, this blockchain-based cryptocurrency is not anonymous. So to achieve anonymous cryptocurrency, we need anonymous signature. And one of the most important anonymous signature is a traceable signature. That is decentralized anonymous signature with double spending detection invented by Professor Fujisaki and me. And combining cryptocurrency based on blockchain and this traceable signature, we can realize anonymous cryptocurrency. In practice, Monero, one of the famous anonymous cryptocurrency, uses our traceable signature in initial version. So this is the agenda of my talk. Okay, first I will explain what is blockchain and how does work blockchain. And next I will explain cryptocurrency based on blockchain, and then I will show you a ring signature and traceable ring signature. And finally, I will show you anonymous cryptocurrency using traceable ring signature. Okay, so blockchain is a decentralized distributed implementation of bulletin board. A kind of bulletin board using a P2P network invented by Satoshi Nakamoto. And the message is written in blockchain. That is a bulletin board. So message written in blockchain is agreed by participants using majority rule and never modified without majority agreement. So blockchain is a kind of bulletin board. So attacker tried to fabricate dummy participants in order to get majority. Majority. And to avoid this attack, proof of work is used. And the proof of work is that to participate in majority voting, one is required to make hard computation related to hash function. So first, I will explain cryptographic hash function. So hash function is H is, for example, in practice, SHA-256 is often used. And anyway, hash function maps arbitrarily long message X into fixed length hash digest hash value H of X. And if message X changes, hash value H of X changes. So modification of message X can be detected by using hash value. And to compute X from HX, that means invert hash function H is computationally hard. And hash value H of X looks random and it's uncontrollable. So to find X such that hash value is equal to 0, several 0 bit is hard because inversion is hard and the controllable hash function is also hard. So it's difficult to find X, satisfy this relation. So to find this X, we require 2L times computation of hash. Fair L is a number of them. So this is an important fact of proof of work. To use this fact, we realize proof of work in blockchain. Okay, I will show the structure of blockchain. A blockchain is a hash chain. That means each block has many data and nonce, that is public randomness, and hash value of previous block. And take hash value of this block, we have next hash value, and the next hash value is included in ith block. And this block also has randomness and messages in this block. And then we take hash value, and the hash value is included in the next block. And we need this hash value should satisfy this condition. This condition means hash value should be smaller than threshold value t. And if this condition is held, block I, number I block is valid. So proof of work is finding nonce n such that hash value s should be less than t, threshold t. So I will explain detail of proof of work. So anyway, so hash value should be less than t. That means hash value with start several zeros, L zeros. So if hash value satisfies this condition, hash value is valid, hash value is correct, and this block is valid. So to find the nonce satisfying this condition, we need to compute 2L hash computation, and that is hard to find. So each miner performs this computation and find correct hash value, correct nonce, and construct valid block of blockchain as a blockchain. And in actual Bitcoin network, it takes 10 minutes to find correct nonce. And so each miner solves proof of work and broadcast new block he create into Bitcoin network. That is P2P network maintaining blockchains. And the blockchain is kept consistent in P2P network as the following process. Blockchain files of blockchain is called ledger or distributed ledger, and ledger is locally kept in each node of P2P network. And the fan receiving ledger with a new block from other node check the correctness of nonce, and that means nonce satisfy this relation, and check the correctness of messages in this new block. And if it is okay. Each node update its local ledger by adding the new block. So in some case, hash chain will branch. Some node create, some miner create new block, and the other miner create new block. So hash chain will be branched. So in this case, we need to select unique hash chain that is valid. So we use longest chain rule. So longest chain rule means the longest chain is the legitimate valid chain. So if there are multiple competing valid branch chains, only the longest chain is valid. So not longest chain is not valid and is not accepted and ignored. So if a chain is the longest in the blockchain, that means the chain is computed by the largest, greatest number of miners. That means the messages in the chain are agreed with the greatest number of miners. So that means majority voting rule decides the valid chain, and the valid message in the chain is determined by majority voting rule. So this is an important rule. Longest chain rule is very important. However, one can attack majority rule by the following, by fabricating dummy miners. So attacker tried to fabricate dummy miners in order to get majority using created dummy miners. However, to fabricate dummy miners, attacker compute proof of work. Attacker find correctness for each dummy miners. So it takes a large computational power. And required computational power is proportional to the number of dummy miners. If the number of miners become large, required computational cost become very huge. So this attack cannot be performed by the attacker. So proof of work is important to prohibit this kind of dummy miner attack. So, however, if attacker has enough large computational power, we can perform 51% attack. That is pointed out Satoshi Nakamoto in original his paper. And that means if the computational power of the attacker exceeds half of all computational power, that is 51%, the adversary can make a short chain exceed the present longest chain. So present longest chain, however, attacker can make other chain the longest chain. So this chain will become valid chain. So that means attacker controls blockchain, valid blockchain. So attacker can write any message into the blockchain. So attacker dominate blockchain. So this attack is called 51% attack. So anyway, in real blockchain network, there are many miners, so there are huge. They have huge computational power. It's difficult to have 51% computational power. So it's difficult to perform this 51% attack. Okay, so if each miner create new blocks, blockchain become longer, and a message will be goes into deeper in blockchain. So message goes into deeper and deeper in blockchain. It becomes harder and harder to be changed, because to change the message here, to change this message, we need to recompute this correct hashness correct hash value and correct nonces, and it takes many computational power, and it is impossible. So, so message goes into deeper and deeper in blockchain. It becomes harder and harder to be changed, and the message becomes unchanged. So this is a mechanism of blockchain. And using a blockchain, we can realize cryptocurrency. So to construct cryptocurrency, we need digital signature. So I will briefly explain digital signature. So there are two participants. One is signer and the other is verifier. So signer Alice generates secret and public key, and Alice generates a signature of a message using her secret key, and the public key is published. So by this algorithm, and the sigma is the signature, and the message and the signature is sent to verifier Bob, and Bob verifies this signature with respect to public key, published public key by this algorithm, and if it by this algorithm. So important point is using public key, anyone can verify the correctness of message and the signature. However, to compute correct signature, secret key is needed. So only signer who has a secret key SK can compute correct signature of message. So that means signer can convince the verifier that the signature of the message is made by the signer. So the message and its sender are authenticated by the signature. So signature is used to cryptocurrency. So I will explain cryptocurrency based on blockchain. So first and most important cryptocurrency, Bitcoin, that is invented by Satoshi Nakamoto. And in cryptocurrency, we maintain transaction information. That means, for example, Alice sent 1 Bitcoin to Bob. So record of transaction of Bitcoin and with the signature of Alice. So if the Alice's signature on this message is correct, Alice agreed this. That means Alice agreed this transaction. And transaction and its signature, its signature is put in blockchain, that is bulletin board, to be published and keep without modification. So this is the basic mechanism of cryptocurrency based on blockchain. So I will explain details. So transaction message TX has this structure. So one is input is sender is Alice, and output is a receiver of Bitcoin. In this case, Bob, and Alice herself, and miner. And Alice creates signature on this transaction information. And the transaction means this transaction message and transaction information and its signature, and denoted by TX. And Alice create TX and broadcast TX into Bitcoin network. Then miner in Bitcoin network perform following mining operation. So first, miner checks transaction information and signature and select preferred TX in Bitcoin network, and bundle chose transaction information after verifying the validity of these TX, and find nonce find nonce and correct nonce. So each block has this structure: TX, several TX, and nonce, correct nonce, and hash value of previous block. And miner find correct nonce of this block. Then, if miner can find correct nonce, miner can create a valid block. Then miner publish broadcast his block into Bitcoin network. So then if block is valid, other miner try to create next block, and other miner try to create next block. Then there are Bitcoin chains. So and these transaction data is keep safely and never modified. So this is a mechanism of cryptocurrency based on blockchain. However, of course, Bitcoin is not anonymous because signature has information, signed as public key. So signed as public key is pseudonym.
Interrupt, sir. Sorry to interrupt, sir. You just have 5 minutes to conclude your session because we are lacking of time. Yes.
Okay.
Yeah.
I will skip. Okay. So anyway, Bitcoin is not anonymous. However, to keep privacy, anonymity is required. So we use ring signature. So ring signature is kind of anonymous signature. So there are many candidate signer, however, including one real signer. And the real signer create ring signature, and the verifier can check one of the candidate signer create the ring signature. However, who is the real signer? So this signature has anonymity. So, however, if we use this ring signature to create anonymous cryptocurrency, there are problems. That means double spending problem. That means if ring signature for two different messages, that means double spending of single coin in cryptocurrency. So this is not good. So we need to avoid this attack. And the traceable ring signature has traceability and linkability. And using traceability, we can detect double spender of a coin. And we reject double spending coin. Okay, so we can combine cryptocurrency based on blockchain and traceable ring signature. We can realize anonymous cryptocurrency based on blockchain. And in actually, Monero is such kind of anonymous cryptocurrency, and that is untraceable, and that uses traceable ring signature invented by Professor Isaki and me. So yes, an initial version Monero using traceable ring signature. However, current Monero using a different simplified version of traceable ring signature. Anyway, Monero using traceable ring signature scheme. Okay, so I conclude my talk. So I explain blockchain and cryptocurrency based on it, and traceable ring signature, and anonymous cryptocurrency using traceable ring signature. That's it all. Thank you.
Thank you so much, sir. Please accept the token of appreciation from CIR.
So are there any questions or comment?
Yes, if anybody has any question, you can ask. I guess, sir, so there is no more questions. So please accept the token of appreciation.
Okay, thank you very much.
Now I would like to request Professor R.M. Mehra, sir, who was the session chair, to deliver the vote of thanks. Over to you, sir.
Okay, good afternoon, everyone, and I'm grateful for all the speakers, four speakers of this particular session. Their presentations on blockchain technologies and applications have been very, very technical and brilliant. And I'm sure that the audience or the participants must have gained a lot of knowledge and also, some future aspect that how they can proceed with the research work which they are continuing or which they want to start in future. So first of all, I thank Dr. Anand Nair, Assistant Professor, School of Computer Science, Due Tan University, Vietnam. It is always a great pleasure that in a particular conference, eminent speakers from international or global countries, they are with us. So thank you very much, Dr. Anand Nair, and your presentation. It was a great interactive. There were so many questions put, and you could explain very in simple words. You can satisfy the queries of the participants or the questioner. Then Dr. Sanjay Mishra, my special thanks to you. As I mentioned in the morning also that we searched you with the help of one of my student, PhD student, and my colleague also in University of Delhi, Professor Anurag Mishra. And it was very nice to hear your little WhatsApp messages because you have been extremely busy and most of the time traveling. And Sanjay Mishra, you have given additional benefit in your presentation. And what Dr. Anand Nair covered, you made a step forward. So in continuation, it is always good that the participants, it seems that it's not a conference, it is just a workshop. So they are getting continuous knowledge one after the other. So I once again thank Dr. Sanjay Mishra. And then two speakers from Japan, I have been interacting with my Japanese fellows at Toyohashi University and Nagoya Institute of Technology. I have been a regular visitor for these universities. And so Dr. Shohei Kakei, Assistant Professor, Department of Computer Science and Engineering, Nagoya Institute of Technology, uh, and Dr. Yashiaki Shirashi, Associate Professor from Kobe. I have been to Kobe University and other places. Dr. Shohei Kakei, I am so grateful to you. I knew that you have been very busy, and Professor Tanamura Sensei actually suggested recommended your name. You have been, he was praising like you like anything. And really, my contacts have been revived. And now in future also, we will be contacting you for our academic activities or the activities organized by me at Sharda University or at CIR, Noida. And then Dr. Kotaru Suzuki Sensei, sir. Sensei, Sensei is teacher. So in Japan, this is a condition mandatory that whenever we meet a professor, we say Sensei, Ohayo gozaimasu. Sensei, arigato gozaimasu. So Dr. Kotaro Suzuki, Professor, Department of Computer Science and Engineering, Toyohashi University of Technology, Aichi, Japan. I think Dr. Suzuki, you must be knowing that in Toyohashi University of Technology, TUT, in Toyohashi, Dr. Wakar actually recommended your a lot of praise also and recommended your name. And I'm sure that Professor Akira Yoshida, who was under whom Dr. Wakahara was working, and I was my first visit, in fact, in 1974, March 1974, was in Nagoya University, and there I worked under Dr. Akira Yoshida. So Dr. Kotaru Suzuki, I'm grateful to you. I'm sure that your presentation in continuous of the previous three presentation was an additional benefit and an additional step. And I'm sure that the members who are present today and the speakers, others speak. No, you know, each speaker give benefits to other speaker also, because everyone field is different. And Dr. Suzuki, you have covered something very, very important, that is blockchain and technology, that is uh, e-cash. Because now 99% all the transaction, bank and other things that they are on online. And so it is something very, very extremely useful to understand these subjects. So thank you all the speakers for your brilliant presentation, informative as well as technical. And thank you, organizer. Thank you, Anisha. You have been so nice. You have conducted the session so well. I'm very happy. So thank you, all of you. Thank you, all of you. And we hope that we meet again. Thanks.
Thank you, sir, and thank you everyone for the patient hearing. Now I would request Professor sorry, sir. Now I would request uh, Dr. R.N. Merrill, sir, to be the session chair of the second session of the conference. May I request Dr. Sunita Yadav, Professor and HOD Department of the Computer Science and Engineering, Ajay Kumar Garg College, Ghaziabad, Uttar Pradesh, India, to address the gathering. Dr. Sunita Yadav is working as the head of Department, Computer Science and Engineering, AKJE College, Ghaziabad, 2011, which is a top-ranked institution. She also worked as an assistant professor in LMC, Cisco Regional Networking Academy, MIT University for 5 years. She got Masters of Networking Technology in Computer Science and Engineering from Kurukshetra University. She has more than 25 publications of national and international repute. Her research area includes search engine optimization, information retrieval, machine learning. Over to you, ma'am.
Thank you, Amisha. Thank you for the beautiful introduction. I hope I am audible.
Yes, ma'am.
Yeah. Okay. So thanks, Dr. Shweta Singh. Thanks, RM sir. And thank you, Shri Sachin Gupta ji. And thanks, Dr. Rudra, for inviting me as a guest speaker in this conference. It's my privilege, and this topic has been always close to my heart. This is a topic which most of the time I'm teaching to my students as well, being a teacher. So artificial neural network, machine learning, artificial intelligence, these been always my subject and favorite subjects to be connected with. So my topic of today's talk will be I may say basics of machine learning. I will try to make the understanding of deep learning as simple as possible. And so that the audience, if students are there or the research scholars are there, if they are using this convolution neural network, a part of deep learning, or I may say deep learning algorithm, they have a clear understanding of this topic. So the purpose of solving or the purpose of selecting this topic, the convolution neural network, is that only that at least you can start using this concept, and the concept is crystal clear to everyone who are listening to me. So I would be sharing my presentation. Is it visible to you?
Yes, ma'am.
And is it on slideshow?
Yes, ma'am.
I will be coming to starting of this. My apologies that I started from the end of the slide. So starting with, I will start with the introduction of why I am taking up CNN and why we are discussing the CNN. So it's been a era we are into artificial intelligence, and we are saying that artificial intelligence, we started with a vision that we are making the machines to think like human, to act like human, to act rationally and to think rationally. And in that journey itself, then we reached on a benchmark called machine learning, in which we are saying that this concept is giving us the opportunity that we need not to explicitly program the computer, but it will learn itself. On continuing on the same journey, we then eager to do something more efficient and I may say something which is more efficient and which can almost replace the way human recognizes the things. So we come on to the machine learning algorithms with brain-like logical structure of the algorithms called artificial neural networks, and these algorithms said to be the deep learning algorithms. So most why we are talking about the deep learning and why we are saying that not all machine learning algorithms, why we were not satisfied till the machine learning algorithms only. So why we are talking about uh, uh, the deep learning algorithms. Amisha, I am getting one trouble, like on my screen, I am getting these names itself, and my slide is not visible purely to me. Okay, now I got that. Thank you so much. Yeah. So as it is there that the design of such an ANN is inspired by the biological neural network of the human brain, leading to a process of learning that's far more capable than the standard machine learning models. So we are trying to somewhat that algorithm is behaving like how the human is doing. So now, these are some of the very known and used algorithms in machine learning, in deep learning, popular, I may say, deep learning neural networks, CNN, RNN, GAN, RBFN, MLP, SOMS, DBN, RBN. I have selected that I will be discussing about the CNN, the most basic one, I may say. And if we talk about deep learning, that is the one which I think we should all know if we are working in that area. So why we need to have, like we are saying, convolution neural networks, then why not neural network has done the work? We are saying artificial neural network is a very good one, which, cater with the variations and all, and the way of, like if I am talking about handwritten character recognition, this is the area in which one of my student has done wonderful work and got many of the public citations into that work. Why, like we are saying handwritten character recognition, in which we used to use the artificial neural network. So why we are now want to switch to convolution neural network? When we talk about computer vision, then we are much more interested in going for the convolution neural network. The reason is maybe the size which we are, like whenever I am saying that if I'm passing an image to a neural network, the size of the input is much. So why we want to go for that? First thing which we may say that the images are very big. If I'm talking about computer vision, images used for computer vision problems, then I can say that the size is 224 by 224. And if I am making it in the RGB colorful image, then multiply by 3. So I can say I have to input this 1,50,000 input features to the input layer. So a typical hidden layer in such a network might have 1024 nodes. So if I talk about how many weights I have to train, so for the first layer itself, I can say it will be 150 plus million weights, which we need to find out, or which we need to, I can say, get the values. So a network would be huge and nearly impossible to train. I am considering that you all are aware of these basic terminologies, that how the weights are, how the network being trained, and what are the weights and how these being adjusted. So another thing is like, okay, we can, whenever I am talking about this much of huge thing, like I am saying 224 by 224, 1,50,000 features, or I can say 150 billion plus billion features. So can I have something else in which I can talk on? I can we talk about that there can be some small features based on, if I talk about like my face, I can say there are two eyes which can be identified by iris of my eye. If I talk about my face recognition, then nose is in which I can talk about that can be, these can be the features, the face, the oval shape of my face, that these can be the smaller I may say the neighboring pixel can help me out to find out these localized features. So it's not like we need many weights either. The nice thing about image is that we know the pixels are most useful in the context of their neighbors. So the objects are made up of small features like the circular iris of the eye, the square corner of the piece of the paper. Doesn't it seems that we are seems wasteful for every node in the first hidden layer to look at every pixel? And so we are making a fully connected network in which we are saying that all the pixels being input to the first layer. That is the first concern, that why we are keen into CNN. Another thing which comes into it is that whenever we are talking about the size of the image, and another thing which we are talking about, that the position of any article in the image may change. So this is something which is there, that if you train a network to detect, let's say, dogs, you would want to be able to detect a dog regardless of where it appears. Like if I have trained into the picture, if I am training a neural network, it is not possible that in all the pictures which I am providing to the neural network, the dog is placed at the same location itself. So there is a possibility that if I am giving, let's say, 1,000 of the pictures to train that the picture of, to identify the picture of a dog, that will be at different locations. So regardless of where it appears in the image, it should be able to detect. So imagine training a network that work well on a certain dog image, but then feeding it slightly shifted version of the image, and it will not work. So now the dog would not activate the same neurons, so the network will not be able to find out it correctly. So we will see soon how a CNN can help us to mitigate these problems. I will be just taking very simple diagram of words and pictures, in which we will be taking it further. So now you look at this, the picture of or a handwritten character 9. So if I look at normally when we look at the pictures, then these are the pixels ranging from 0 to 256 values. But here I have taken the values in which 1 and -1 I am using. That if in the pixel, the picture is coming, I am taking that as 1. Otherwise, I am taking it as -1. So if I am considering this as, you can look at this one, but if this picture shifts, now you can see that whenever we are feeding it to the neural network, it take like 1, 1, 1, minus 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1. Now, if you talk about this one, this is the same one exactly, which is taking up. If I am giving, if the picture, or I may say, if this 9 being shifted slightly to the right, you can see that the whole thing being changed, and it will not be taking it exactly as this one, which is a big problem, that if a article and object being changed into the picture, then we are unable to identify that. So this is something which is, if we talk about the variety into the writing, then we are saying that artificial neural network is very well handling that one. So that we have done, like, okay, in some of that, maybe I have written a bit changed 9. So that artificial neural network is handling well. Now let's come on to the first thing itself, the bigger size. Let's say take the picture of this koala, in which we are saying that this image is 1920 or 1080 into 3. So we can say that the first layer will be having the neurons, approximately 6 million neurons. Let's say we are having the hidden layer neurons, approximately 4 million. So if we will talk about how many weights we need to train for that, or we need to find out for that, that will be approximately 24 million. So now what's this? Like, okay, if it is a fully connected network, then this can be this much size can be into the weight training size can be this much. So can't we reduce that? What can we do into that? So from this fully connected model, do we really all the edges? Can't we compress it? Or can't we do some sharing? Like if I am saying I, means why I need to check out, or why I need to, can't I make it as I filter for, or I can say some identification for one eye, so that will be the same applicable to another eye. So on my face, if there are, let's say, imagine 5 eyes are there, so only one identification thing should be there, which is able to identify it. So this is something, I may say, the motivation behind the CNN, that why we should be doing and entering into CNN. So these are some of the disadvantages of ANN. We were using ANN earlier, but now we are onto the emerging edge, and so we are saying that, okay, what are the problems in ANN can be now faced by some new algorithms, and the computation, as I have discussed, it treats the local pixels same as the pixels far apart and sensitive to the location. Like here I am saying that, okay, some patterns are much smaller than the whole image, like the beak. So beak can be identified. So consider learning an image, how a human learns that. Like if you are looking at my face, then how you recognize me? You first look at my eyes, then maybe my nose, my lips, my ears, and then hold together, you make my face in your brain. So this is the way it is working. That's how we are saying that, can we do some small feature identification and then club them together, and then we can identify the whole image. So this is something which is acting behind this. Like from this specific picture of this bird, we are just finding out the beak. Then the beak, I can say that if I am making that the process of identifying the beak only. So if the beak is on the left, maybe on the left side. So if I am making an identifier of the beak, then I may say that if a different picture will come in which the bird's beak will be in the center of the image, it will be able to identify. So what about training a lot of small detectors, and each detector must move around? Like if I make a beak detector, then I am saying that I will be, moving that beak detector throughout that image. And let's say there are 5 birds and 5 beaks are there. So I am finding out 5 beaks there. In this, the variation will be handled. There can be another thing in which we are saying, let's say this is a upper left beak detector. That can be if I have compressed the image, or if there's a different image, then we can say there can be the beak detector which work into the middle as well. Now let's consider this again, the case of this koala, in which we are saying that how we are identifying it. We are looking at the eyes of this koala. Then we are looking at like how I come to know that this is a picture of a koala. So I first identify the eyes, the nose, then maybe the hands, and then maybe the body, the paws, and then clubly when I look at this, I find out, okay, this is a koala. So I'm saying, okay, looking at the nose, eyes, the face, I find out that this is the head of the koala. The CNN is exactly trying to work in a way how human brain is thinking. So when I look at this part, I'm finding out, okay, this is the body of the koala. And finally, when I club both of these, I'm coming to know that yes, this is koala. Like the 9, this image of 9, handwritten 9. I may say how I identified 9 can be written in what way. I know there is a loop being made up of, then there is a standing line, and then there is a diagonal line. So I may say that this loop is consisting of, there is a upper arc, then there is a left arc, and then there is a diagonal kind of structure made up of this one. And I may say that this is a loopy circle pattern made on the 9. I may say that that same kind of structure being made at 6 also, but on a different place. Then I am saying that there's a vertical line which is there, and then we are saying that there is a diagonal. So we can say that these parts I am identifying. When I am looking at this, I am actually looking at this. Let's say there is another loop over here. So what I have find out as a human, what I have find out, that if there is a loop here and again there is a loop over here, I am considering that that will be 8. I know that if this is a loop and then there is a vertical line and then there is a horizontal or diagonal line, then that can be 9. So we are making these small features. So how can we make computer recognize these teeny features, which we are saying that in the case of koala, in the case of this 9. Now this do by using the convolution layer. Now what this convolution layer is doing, a CNN is a neural network with some convolution layers, and convolution layer has a number of filter that does convolution pattern. So I may say that this is, let's say, the picture, the input, then it has these convolution layers into it. So convolution layer, let's say I am applying a filter over here, let's say a beak filter, beak detection. So it is applying a filter over here, a filter over here, a filter, the same filter over here, and so on. And then it is able to find out that there is a beak over here. Convolution operation being done into this. Like I may say these can be the features, filters which is shown over here. Filter can be like this is a diagonal filter, this is a horizontal filter. So these are the network parameters to be learned. Like this is the example. Like you can say that whenever I am taking this 9, Then in this 9, I am saying that there is a filter, a loopy filter, a horizontal filter, a diagonal filter. These are the filters which we are trying to make it learn, or I may say which we are applying onto this, which we are, if it can be 1 filter, 2 filter and 3 filter, which we will be applying onto this image. Now, how we are going to apply onto this image? I can say that, let's say this is the whole image which we are taken from this one, -1, 1, 1. This is the input image. Then I am saying that there are 3 filters. Why I have taken the 3 filters? Because I have seen that the 9 is made up of 1 loopy circle, then a horizontal line, then a diagonal line. So I have taken first filter, and then I have moved this filter over this whole image, and we call that as a stride. Stride 1, stride 2. Stride 1 means we are moving it once, after one skipping the 1 pixel only, or 2 if we are doing that, we call stride 2. So we are calculating this, and this is the calculation, like 1 is multiplied with this one, plus 1 is multiplied with this one. So we are doing a dot product into this, and then we are finding out the value, this one. Then stride 1, and again we are having this 3 by 3 matrix over here, and again this 3 by 3, we calculate the value, paste it over here. Then again stride by 1, and we take this one, dot product with this one, and we find out. And like this, we find out this feature map. We find out this feature map. So this we call the feature map, which we are calculating. So this is the convolution network we are doing. The process is showing if we are taking stride 3, stride 2 means exactly we are shifting from this to directly this one. So we can take stride 2 or stride 1. So likewise, it is making the values. Keep on doing. We got a feature vector for 1 filter. Try to remember that 1 filter is, let's say in the case of 9, that was the loopy filter, 1 filter. Let's say if I'm talking about the koala picture, then in that I may say that that was a eye detector. So that been once rotated over the whole image, and then we have made up this feature map. Another filter we will apply, and again we will be having another thing. So we keep on repeat for the other filter, another feature vector we will be getting over here, feature map we will be getting over here, and likewise we will be having these features. So now if, let's say I have applied a loopy pattern detector over 9. So I will be getting in this image, I will be getting a 1 over here. Fine. Why a 1 over here? We are saying that we are calculating the values, and whatever the value is coming, we are keeping it over. In this, if you look at, because this is the same thing, 9, we are saying the circular pattern of that 1 we have applied over here. And if you look at this, that because here also it is the same, in the input picture also it was exactly the same. So if you calculate and find out the value, you got that the 1 is on the top only. So if the 1 is on the top only, now you look at that whenever I am making a convolution of, whenever I am making a convolution on these, then I am finding out, okay, this is the loopy pattern over here. And so when I apply the same filter onto this, the 1 comes over here. In the 8, if I apply this loopy pattern, the 1 comes over here, the 1 comes over here. Let's say there is a 96 and the picture in the input, if we are saying 96 is written over here, then there is a pattern over here for 1 and the pattern here for the loop. So the filters, I may say that these filters are nothing, but these are the feature detectors. These are the feature detectors. So if we look at this koala picture, let's say if there is a eye detector, I am applying onto this, then it will be having one eye slightly over that. In the right hand side, there is another eye. So it means I will be getting 1, 1 on these locations. Rest, I will be getting some other values which are less than 1. Here, if I talk about this one, on which if I am applying, I can get that these are the 1, 1 which I am getting. Let's say if I apply on this picture, the eye detector I have applied on. So there is 1 eye over here, 2 eye over here, then 2 eyes slightly below that. So I am getting these 1. Let's say I am clubbing all these and then, sorry, okay. So let's say there is a hand detector. So I am getting a hand over approximately here in this location. Rest of the things will be some other values. So if I look at this one, the first one, so I can say that if the 1 is on the top in the middle, if I applied the vertical, you can see here that this is a vertical filter which I applied onto it. So if I apply the vertical filter, it is on the middle, it is having the highest value, 1 value. If I apply on the diagonal filter, then we can say that is there. So how many filters, then I can say that 3 filters if I will be applying, this will be able to identify the 9. And these can be the feature maps. These are the feature maps which I find out after applying these 3 filters into it. Like this for the color image, if we are having 3 RGB, we are having channels. So we are making the maps. Now you can, likewise, you can see that these 3 filters, like the eyes, nose, ears, can be clubbed to make a multi-dimensional head filter. So it's not necessarily important that always the filters will be 2-dimensional only. The filters can be multiple dimensional as well. So let's say this is a filter which is having the dimensions in which eyes, nose and ears are connected. So we can say that we have find out that head is here. Likewise, there can be another filter for hands, legs combined together, filter for body, and so here is the body. And when we club these two, then we will be combined way, we will be able to recognize, or the network will be able to recognize that this is body of a koala. So this part which we have done, that the filters been applied onto the image, and then we call the feature map being find out, we call it feature extraction. Then whatever features into the feature map, we flatten that. Flatten means, like if I am saying 0 1 0 0 1, so I am writing here 0 0 0 1, and then the next line I am writing over here, then the next line I am writing over here, that is said to be flattened. After that, these things given to the classification, the input layer of the densely connected network, and then it will be identifying whether it is by using, this is a densely connected neural network. So again, the thing which comes over here is that there is an operation. I have explained till time only the operation convolution. So if I am talking about other operations which is done after convolution is ReLU operation. So what is this ReLU operation is? It helps the model the non-linear. It helps with making the model non-linear. In the ReLU, we can say that this is a rectified linear activation unit, a piecewise linear function which returns.
Sorry, ma'am. Sorry to interrupt. You just have 5 minutes to conclude the session. We are going lack of time. Yes.
Yeah, sure.
Thank you.
So in the ReLU operation, we are, in short, I can tell that the negative values been made 0 and only the positive values being taken as is. From here to here, you can find out that rest are made as 0 and this being made as 1. So here you can, again, we are worried that, okay, that can be done. In ReLU operation, again, we have made it non-linear, but the size issue has again been the same. I am passing out 0, 0, 0 and 0, 0, 0, 1, 0, 0 into it. The size has not reduced. So what can be done? How we will be doing? That we will be doing by pooling. So what is a pooling? Pooling in which, let's say this is a max pooling, in which we are saying that, okay, this is a feature vector in which I am taking it up, the values, and I'm just replacing these 4 2 by 2 matrix into a 1 by 1. So I am taking maximum out of it. It is 8, maximum out of it, it is 9, maximum out of it, it is 3, maximum out of it is 2. And this is by a stride of 2. By this time, I think you understand that what is the stride? Switching from here to here. Exactly. Not to this one. If I have done this one, it means that is a stride of 1. So now pooling in other sense can be done. Think of that we have just done a subsampling of this. We have just done a subsampling of what was there. Max निकाला है हमने, जो value which was there, which is max into it, we have taken up that. So according to that feature vectors, this is the one where the maximum filters fit in. So that is a subsampling. So the pooling can reduce the dimensionality and computation. It reduces the overfitting as there are less parameters. Model is tolerant towards the variations and distortions. And so we have seen that there are 3 things which come into. One is convolution, another is ReLU, another is pooling, which we are doing into it. So max pooling can be there, like this is there, and we have find out the max pooling into this one. So I will skip this because I'm left with less time. So like here, I have seen that after doing a max pooling, we get a new image and we keep on repeating this thing. A new image is we are doing convolution plus ReLU, max pooling, then again convolution plus ReLU on the image which we got, then again image, and then a not fully connected but densely connected network. So ultimately, coming on the summarization, now we can see that here we input the image, perform the convolution and ReLU using the filters, and then doing max pooling, again doing the convolution and ReLU, then using the filters, doing the convolution. Here, let's say imagine eye, nose, and ears done, then pooling done, then head, nose, head body filter, then pooling done, and so on after n number of times. Now the beauty of this CNN here is the value of these filters we are not passing. This the number and the size though we are scaling, but we are not passing the values into that the CNN will automatically be recognized as the part of it training. So then this is how the feature extraction being done, and then these being passed, flattened, these being passed, to the densely connected network and then being classified using the densely connected network. That's all from my side. I would like to have questions if anybody has.
Thank you so much, ma'am. I would request the audience if you have any question, you can ask. I guess there is no question, ma'am. Please accept the token of appreciation from CIR.
Okay, thank you so much.
Now I would request Professor Anurag Mishra, Professor Department of Electronics, Deen Dayal Upadhyay College, University of Delhi, India, to address the gathering. Dr. Anurag Mishra is working as a professor in Deen Dayal Upadhyay College, University of Delhi from past 23 years. He got his MSc and MTech and PhD degree in electronics and computer science from Delhi University. He is certified in embedded systems from IIT Delhi. Currently, he is around 40 research publications to his credit. His research area are artificial intelligence, learning, image and video processing, information security, medical application of deep learning. Over to you, sir.
Thank you. Thank you. Am I audible?
Yes, sir.
Okay. Thank you very much, the Sanskriti University and CIR for inviting me for this talk. And I especially thank my teacher, my supervisor, Professor R.M. Mehra, sir, that he has connected me with this network and invited me for this. And what should I share? I screen, I suppose. How would I be presenting? When this is disabled, I think. Excuse me.
Yes, sir. We are making you the host. Yes, sir.
I'm unable to share my screen actually.
Yes, sir. Wait a second. We are making you the host. Then you will be able to share this.
So I think my presentation is visible.
Yes, sir.
Okay. Just a moment. Just give me 1 minute. Okay. So today I'll be speaking on blockchain security issues. So this is a very introductory kind of tutorial, which is especially meant for the students who are into their undergraduate program or postgraduate program, or those who are intending to study these things. This is, this is in, especially in India, this research area is picking up now. And in this budget provisions, in the current year's budget provision, the government has, up to some extent, they have given, you see, claimants to this cryptocurrency also. Now this, we must understand what is this and what are the security issues related with Bitcoin and blockchain framework. Now this Bitcoin cryptocurrency in many ways is analogous to the Internet of Money, and this is basically a network meant for propagating the commercial value. Just like we go for a paper currency, we go for some kind of digital currency. So in the same league, this is a third type of currency which has been added. It attempts to secure the ownership of digital assets through distributed computation, which is the old technology. Distributed computation is the old technology. It was there since last 20-25 years. So, but on the other hand, it is an innately trust-based, insecure, and potentially vulnerable environment. Now, what are the issues related to security? Whether the money is authentic or non-counterfeit. What I am getting is authentic. That must be there. Can I be sure if this money belongs to me and only me? That is if this money belongs to me only. Our decentralized distributed network is essential for secure cryptocurrency. So obviously we have to make secure our distributed network for this purpose. We must understand this. Now, what is a Bitcoin framework? It is a four-layer architecture. Now, a decentralized peer-to-peer network, that is the Bitcoin protocol. This I'll not go into the details of this architecture because my previous presenters they have already taken up these things in detail. So I'll be more focused towards the security issues. Public transaction ledger, that is the blockchain, a decentralized mathematical and deterministic currency issuance framework, that is a distributed mining, and decentralized transaction verification system, that is a transaction script. Once the transaction script is issued, that means the transaction is complete. Now, besides the architecture, there is an issue of scalability as well. Every node in the Bitcoin network maintains the ledger for all the transactions that have occurred over the network. This sums up to several hundreds of GBs of hard disk space, and it keeps on growing. This increases the cost of memory and computation for mining of the Bitcoins, which is a peculiar problem, adding to the complexity of the process, which leads to the scalability issue. And this scalability issue further complicates the security concerns. Now, how the cryptocurrencies, what are the issues involved and how the theft is carried out? The theft of cryptocurrency generally carried out through hacking of exchanges or marketplaces, hacking of individual users' wallets or exchange accounts via malware, using remote access Trojan programs, specialized cryptocurrency stealing malware. So the biggest theft was known as MTGOX of Tokyo, Japan, which used to handle 70% of the Bitcoin worldwide. This was considered as a combination of theft, fraud, and mismanagement. And this is the series of history of exchange hacks which have been carried out by fraudsters on this technology, that is MTGOX in 2011 to the tune of $450 million. MTGOX again 2014, that is $350 million, and so on and so forth. And the source is also mentioned here. So if someone has some query over these, if the person wants to go into the details of these hacks, then this link can be searched out. Now, I'll talk about stealing malwares, cryptocurrency stealing malware, CCSMs. This is for the first one is the wallet thief. This malware searches for the file wallet.dat and well-known wallet software key storage locations. For this purpose, the file is uploaded to a remote FTP, HTTP or SMTP server where the thief can extract the keys, steal the coins, and transfer the coins to the thief's address. Keylogger monitors to retrieve the passphrases or passwords which users use for additional security to their hard disks. Then we have credential stealing. Several exchanges may implement two-stage authentication. This is just like a banking software. We know how this works actually. Several exchanges may implement two-stage authentication using one-time passwords, OTP, to tackle unauthorized login. This is similar to banking system, but still, the advanced malware can bypass OTP-based two-stage authentication by intercepting the OTPs. The malware can further create a hidden browser window to log the thief into the account from the victim's computers. Simultaneously displays a fake authentication field message which blocks the victim's access to the website. This is another old technology, remote procedure call, which is specially designed for distributed computing. And here, since this is all distributed platform, so this RPC vulnerability is again a major issue in this case. The Bitcoin reference client software includes the RPC functionality. This RPC is an old practice among the internet users. This allows another program to interact with the wallet software. A thief with access to this functionality could connect to a running client using a local TCP port and steal the balance of an unencrypted wallet using only two commands. So these are the type of, problems we used to face. Then we must find out certain solutions to these problems. So therefore, if they cannot be totally avoided, but they can be minimized. So what are the solutions? So blockchains, we will look into the solutions now. Blockchains make use of three types of cryptographic algorithms. These are symmetric and asymmetric key algorithms and hash functions. These are all type of algorithms which our students used to study in their undergraduate or postgraduate programs. Hash functions are used to provide a functionality of a single view of blockchain to every participant. Everyone who has studied data structures, he or she is familiar with hash functions. Hash functions, they know that the hash function, they converge to a single point, either a single location or a single data value. Okay, so this hash function, but how this hash function will be applicable here, we will see. Blockchains usually use SHA-256 hash function for their protection. Now, how the cryptography is used in blockchain security cryptography, as I told you that the encryption, decryption of data, two main cryptographic concepts are used in blockchain, the hashing and digital signatures, and symmetric as well as asymmetric cryptography is used. Symmetric cryptography means same password to encrypt and same password or same key to encrypt and decrypt will be used. Asymmetric means we will use a different password or key for encryption and the second one for decryption. And hashing is, again, I've told you, it maps to a fixed location in data size. And in case of symmetric cryptography, it is a two-way function. Asymmetric means it comes with pair because both the things are different, so it comes with pair. And hashing is a one-way function. It cannot be reversed. Symmetric cryptography is a two-way function because it can be reversed also. Now, types of encryption used in blockchains. Bitcoins are also called cryptocurrency because its digital signature algorithm uses the same mathematical techniques used for a type of encryption based on elliptic curves or elliptic curve cryptography or ECC. Bitcoins use elliptic curve digital signature algorithm, ECDSA. We will discuss these things later. It's a two-way process, means it can be reversed as well. Hashing. This is a one-way process. It cannot be reversed. In this case, the plain text is scrambled into a unique digest through the use of a suitable function that cannot be decrypted. So therefore, it is a one-way process. So this thing cannot be decrypted. If a proper hash function is used like SHA-256, the probability of altered code having the same hash value is around 2 raised to power minus 256 for SHA-256. This simply means that this is virtually impossible to decode it. You see, you can have you can look at the probability value. This probability is very, very less. This is nearly zero probability. So therefore, this is practically impossible to decode. Now, graphically, we will look into these things. The first one is the hash function. This hash function is giving rise to a single location or a single data. Then the symmetric key, you can see yourself that the same key is used for encryption and the same key is used for the decryption. And the output of the decryption is the same output, which is encrypted. In case of asymmetric encryption, we have used a different key, public key for encryption and a private key for decryption. This is one example of hashing. Say our input is 2345 and we apply a modulo 15 hash function. So the answer would be 5. And in case of symmetric encryption, 2345 is the input and we apply minus 1 convoluted with 2345. So this will be giving to minus 2345, which is just beyond this, beneath this lock, minus 2345. And when we apply a symmetric key for decryption purpose, that is again minus 1. So what we get is the same value which was encrypted beforehand, 2345. So asymmetric encryption, in case of asymmetric encryption, we will use a different public key and a different private key. For 2345, we will use 1 by 3 convoluted with the input value. Then what we get is minus 781.666. And the private key is convoluted with 3. Private key is convoluted by this value. So our answer will be 2345. This is SHA 256. So the input is hello and the SHA 256 is applied. So what we get is this. So this is one-way process. I mean, this cannot be reversed back. Symmetric encryption, AES 128 hello, encrypt with 128-bit AES algorithm. Then we decrypt it and then we get hello again. Asymmetric encryption, RSA. Now, then asymmetric encryption, SECP 256K1. So they are different variants of different algorithms for asymmetric encryption. Now you can see RSA has got a key size 1024. We will discuss about this later. Yes. So now we come to elliptic curve cryptography. Now ECC, an alternative technique to RSA algorithm, is a powerful cryptographic approach. It generates security between key pairs for public key encryption by using the mathematics of elliptic curves. Here, basically, if one has studied cryptography a bit, then the person knows that initially AES and RSA algorithms were very popular. And then as a substitute for RSA, the ECC algorithm was developed. So obviously the output and the performance of RSA is usually compared with that of ECC algorithm. So here we will do the same thing. The RSA algorithm will be thoroughly compared with ECC in this presentation. RSA does something similar with prime numbers instead of elliptic curves, but ECC has gradually been growing in popularity recently due to smaller key size and ability to maintain security. The outputs which are possible with 3072-bit key size using RSA are generally available with 256-bit key size using ECC. Now this is ECC. For current cryptographic purpose, an elliptic curve is a plane curve over a finite field rather than the real numbers, which consist of a point satisfying the equation y raised to power 2 is equal to x raised to power 3 plus ax plus b. And when we plot this equation, what we get is the figure adjoining it. Now, again, we come to the key size. RSA key size, you can have a look on this: 1024, 2048, 3072, 7680, 15360. This is the key size. And obviously, when the key size is such a huge key size, then obviously it takes time for computation. ECC key length is 160, 224, 256, 384, 521. Now, what we have to understand a pattern among these. We have to understand a pattern. There is no linear relationship between the sizes of the ECC keys and RSA keys. That is, an RSA key size that is twice as big does not translate into an ECC key size that is doubled. That means if 160 key size for ECC is sufficient to produce a similar output as that of 1024 in case of RSA, that does not mean that with the same multiple, we will get the same kind of output for 521 and 15,360 key size. So there is no linear relationship between these. This is very, very important actually. And this makes actually ECC algorithm very powerful. This compelling difference shows that ECC key generation and signing are substantially quicker than for RSA. Obviously, because the key size is very, very small, so it performs well, it gives security and within no time. That is, so therefore it can be applied in real-time scenarios like blockchain security. And also that ECC uses less memory than does RSA. Also, unlike in RSA, where both are integers, in ECC, the private and public keys are not equally exchangeable. Instead, ECC, the public key is a point on the curve, while the private key is still an integer. The main disadvantage of ECC is that it is not easy to securely implement. Compared to RSA, which is much simpler on both the verification, that is decryption side, and encryption sides, ECC is a steeper learning curve and a bit slower for accumulating actionable results. However, though with RSA, and so is the decryption and signing, which aren't always easy to implement securely. However, to remain secure, RSA needs keys that are 2048 bits or longer. This makes the process slow, and it also means that key size is important. Size is a serious advantage of elliptic curve cryptography because it translates into more power for smaller mobile devices. It's far simpler and requires less energy to factor than it is to solve for an elliptic curve discrete logarithm. So for two keys of the same size, RSA factoring encryption is more vulnerable. Then we come to the digital signature, which is based on elliptic curve digital signature. Elliptic curve digital signature algorithm uses ECC keys to ensure each user is unique and every transaction is secure. Although this kind of digital signing algorithm offers a functionally indistinguishable outcome as other DSAs, it uses the smaller keys you would expect from ECC, and therefore it is more efficient. So this was a brief idea about the security issues, and then we can summarize the things. Security is an important issue in the blockchain architecture. All kinds of encryption, symmetric and asymmetric, including the hash functions and digital signatures, are used to ensure security. The research is a cutting edge as this area is growing exponentially, and so are its security issues. Thank you very much for patiently listening to me, and over to again the hosts.
Thank you so much, sir. Please accept the token of appreciation from CIR.
Thank you, Ben.
Now I would request Dr. Prakash Srivastav, Associate Professor, Department of Computer Science and Engineering, Dehradun, Uttarakhand, India, to enlighten us with his words. Dr. Prakash Srivastav is working as an Associate Professor at Graphic Era, Dehradun. Earlier, he worked at KIT, Ghaziabad, and he got his PhD in Computer and Science at Madan Mohan Malviya University of Technology in 2017. He pursued his master's from NITTR, Chandigarh, and BTech in Science and Engineering from IERT, Allahabad. He has published around papers till date. His research areas include mobile ad hoc network, UOC, wireless sensor network, and data science. Over to you, sir.
Hello, good morning, all respected dignitaries and the participants who are basically attending the conference. Today, I'll give the expert talk on blockchain technology, which is basically a nowadays very emerging technology in the phase of these financial in the persons of the secure financial transactions in a distributed fashion. Before going to the details of the blockchain, First of all, we should understand the concepts of decentralized versus distributed network versus decentralized network. There is basically a vital difference between centralized, decentralized, and distributed network. Centralized, basically all the nodes will come under a single authority. Decentralized means there is no central authority, okay, and everyone can take part in the network. Distributed means independent nodes interact with each other, and also each node is interconnected. See here in the diagram, you just see this is centralized network. There is no such there is a single authority to control. Distributed fashion, okay, independent nodes can basically interact, and decentralized, they are basically linked to each other, okay. What is blockchain? Everyone nowadays have listened about the cryptocurrency and about the blockchain. Blockchain is basically a way to secure the financial transaction in a distributed fashion. So it basically blockchain is a system. It basically comprised of transactions, immutable ledgers, decentralized peers, encryption process, consensus mechanism, optional smart contracts. Let us explore these concepts. What do you mean by transaction? Transaction means set of sequence of events that are required to be conducted for the purpose of executing the transaction. As with enterprise transaction today, blockchain is basically a historical archive of decisions and uh, action taken, and basically the proof of history of the transaction provides the validity, provides the basically an invention to the secure transaction. So in the real life, many applications are there where we require the secure transactions, so that any of the hacker, any of the other intruder should not hack the system, or should not tamper the data related to birth record, related to land registration, related to transportation sector, banking sector, manufacturing sector, food distribution sector, audits. These all in this basically all areas where we require the secure transactions need to be happen, and it will only be secure unless and until if we do the transaction in basically in a decentralized manner. Means every one of the parties associated with the transaction should know about any of the tampering of the data at their nodes. They should automatically be reflected on the other nodes that the data has been changed, so that the participants of the network should know about that, and we are able to know where the data has been changed, and we are able to find that particular security breach also, so that we can. So basically, how do we do that particularly? So basically, for the purpose of this blockchain transaction, we generally use the concept of basically cryptography and digital signature, and basically preferably the hash function is used, okay. And for blockchain, the transaction must be immutable. Immutable means, as with existing databases, blockchain retains data via transaction. The difference that it is, once it is written to the chain, means once it is written to the blocks associated with the blockchain, it is extremely difficult to change that particular transactions that are being written in the block, because they are being linked with the hash function, with their respective hashes, requiring network on all subsequent blocks, and basically consists of each. Any of the transaction that are required to be happened, it should be agreed by all the nodes that are basically participating in that particular distributed database transaction network. The transaction is basically immutable, or it is basically indelible. In database administration terms, blockchains are basically read and write and read only. Like a ledger written in ink, an error would be resolved with another entry. Okay. Decentralized peers. What are decentralized peers? Rather, the centralized hub and spoke type of network. Blockchain is basically a decentralized peer-to-peer network. Means every node can interact with another node in a blockchain, and also they can communicate with their message regarding the security breach, regarding the writing of the transaction, what are the regarding the update of the transaction, if any record. But it must be consensus, it must be approved by all the parties that are basically participating in that particular transaction. Rather than a decentralized hub and spoke type of network, blockchain is basically a decentralized peer-to-peer network where each node has a copy of the. Then coming to the encryption, in the blockchain, basically standard encryption practices are basically followed. Some blockchains basically allow for BYOE, bring your own encryption, only as good as the next hardware innovation. For example, basically blockchains generally use the concept of hashing function. How typical is the hashing function? Hashing function should not be reversible. Okay, means if you have created the hash of that particular message, it cannot be reverted back by using that particular hash. Even if the small change in that particular message, it will reflect a great change. Only as good as the next hardware innovation. All blocks are encrypted. Some blocks are public, some are private. Public blockchains are still encrypted, but are available to the public. Private blockchains imply their rights for visibility, customer rights, and reviews all data. Auditors, basically it views all transaction. Suppliers means the party which are basically using that particular transaction. Writes and views partner A data. Supplier view writes and views partner B data. What is consensus? Because consensus mechanism is a very important factor in the blockchain. Consensus mechanism is used in blockchain systems to achieve the necessary agreement on a single data value or a single state of the network among distributed nodes in peer-to-peer network. Commonly used consensus algorithm is basically proof of work and proof of stake. Means consensus means that there should be an agreement on a single data value, or if there should be an agreement of the particular transaction being held. So proof of work is basically a requirement to define an expensive computer calculation, also called mining. Means if any of the transaction being recorded, it has to undergo through a complex mathematical procedure to show the proof of work. Means it is added. It should not be just we can add the transaction. We can record the transaction in a very simple. We have to do some mathematical calculations also. We have to do some. We have to perform some mathematical procedure to record the transaction. Otherwise, if it is so simple, then any of the transaction can be recorded. So since it is a blockchain, the purpose is to secure the transaction. The purpose is the distributed the purpose is basically distributed database transaction. So all the parties must agree on that particular transaction. That is known as consensus. And then proof of stake is basically proof of stake is basically the creator of a new block is chosen in a deterministic way depending on its wealth, also defined as stoke. Okay. So these are all basically the aspects of the blockchain transactions that we have discussed. So brief history of basically blockchain. On October 31, 2008, Satoshi Nakamoto released the Bitcoin white paper. You can navigate through this link also. Obtain a purely peer-to-peer electronic cash digital asset transfer system. They have applied the blockchain technology on the digital currency, or known as basically digital cash or electronic cash. This is the first popular implementation of the blockchain and is attributed, means today the various cryptocurrencies are basically coming in the market are basically using the blockchain technology. Okay, this is the first popular implementation of blockchain and is attributed as birthing today's blockchain industry. From there onwards, the first basically crypto coin that has been invented is Bitcoin. All of you know about that, and after that Ethereum and many of the coins on the daily basis have been reflected in the cryptocurrency market. Since these additional blockchains have been popularized, Ethereum, various Hyperledger project solutions, as well as numerous others, including blockchain-like solutions such as guard-time KSI products. What do you mean by smart? Then coming to the smart contract. The smart contract is basically a set of procedures. Is a computer program which execution is autonomous and totally transparent. In particular, this execution cannot be reverted and its trace is public and immutable. Okay. So smart contract is set of procedure and its procedures are written. It cannot be altered. Okay. Then smart contracts, if you see the aspect, this option contract written as code into blockchain. Contract is part of the public blockchain. Parties involved in the contract are basically anonymous. Contract executes itself where the conditions are met. Regulators use blockchain to keep an eye on contract. So regulating agencies keep what are the various procedures being adopted is as per the smart contract or not. If you see the detailed about the blockchain transaction, see a transaction is requested to the distributed network. The requested transaction is broadcast to the peer-to-peer network of nodes. Then it is validated. The network of nodes validate the transaction following the protocol. A verified transaction can involve any digital assets. Okay, once it is verified, the transaction becomes a part of new block for the ledger, and then it is added to the particular blockchain. The new verified block gets added to the existing blockchain. Then transaction is, if you want to add the transaction block, then we have to adopt these basically procedures. Okay, audience, I hope you have. Thank you for the patience listening. Okay.
Thank you so much, sir. Please accept the token of appreciation from CIR.
इसको थोड़ा म्यूट कर दो.
Now I would request Dr. R.N. Beral, sir, session chair, to deliver the vote of thanks.
Thank you, Amisa. With this, we come to the end of technical session 2. We had 3 speakers in this particular session. The first speaker was Dr. Sunita Yadav. He explained the basics of machine learning, deep learning, convolutional neural network, ANN, and these are, frankly speaking, very complex topics, but she spoke very well and very beautifully explained in plain words. The second speaker was Dr. Anurag Misra. He spoke on blockchain security issues and also he explained the resolutions. The other topic he explained are Bitcoin framework, cryptographic algorithms, and so on. The final speaker of this particular session was Dr. Prakash Srivastav, and his topic was blockchain technologies, which is an emerging era in the days to come. All the deliberations were very informative as well as very interesting. We thank all the speakers for gracing the occasion by their presence. Thank you so much. Over to Amisa.
Thank you, sir. With this, we came to the end of the conference. Hope you all had learned something new. Stay tuned with us on CIR.in. Thank you, everyone, for being connecting. Thank you.